Let's try it again. So yes, examples of unit of measures are milligrams, ounces, milliliters, grams, micrograms, drops per minute, milliliters per hour. These are all examples of a unit of measure. And without including the unit of measure, how will I know what I'm giving? Also included are tablets and capsules. These are all units of measure. So I wanted to talk quickly about intake and output. So intake and output basically means what we take into the body, and this would be our patients. So what are some examples that we would include is intake? Can anybody think? How would I know what to include?
Anything someone drinks?
Right. And it's a liquid. If somebody drinks something, it's a liquid, that's part of intake because when we do intake and output, we always measure it using milliliters as the unit of measure. So when you are working as a nurse, or even if you are currently working as an LPN or a care partner or a nursing assistant, when you document on the intake and output, you should be documenting in milliliters. All right. So when we say in, it means what the patient is taking in. So you had mentioned what they drink. What's another example of somehow milliliters getting in the patient?
IV fluids.
IV fluids. We're putting it into their vein, into their body. So IV fluids. Um, we've got oral. What else?
G-tube.
Yes, an enteral feeding. So
Enteral.
that's called an enteral feeding. And that's a way to feed a patient using liquid nutrition that gives them calories, fat, and protein and all the good nutrients. But they can't take it through their mouth because there's a problem with their swallowing. So we give it through the stomach, directly into the stomach or intestines. So those are all ways of getting intake. So what are examples of output?
Urine.
Yes, urine.
Diarrhea.
Diarrhea because it's liquid.
Vomit.
Vomit, which is also called emesis. Yes. One more thing. Can everybody think about it? So wound drainage. If we have a wound that has a drain on it, we can measure it coming out of the patient. So if you can capture it in a container, it's liquid, it's out and it's coming out of the patient. So wound drainage. So these are all things to keep an eye out in questions that have intake and output. So always remember intake and output. Number one, if I ask you the total intake and output, I don't need one big number like 5,000 as both. No, intake is always two separate numbers. What the patient put in their body or what we put in the body of our patient. Their intake is one answer in milliliters, and then their output is another answer in milliliters. And the reason we do this, and you'll learn as you go through your nursing courses, is that because what we put in should come out. And this is called a hemodynamic and making sure our patients have a good fluid balance. So what goes in should come out. And if it's not, and there's a deficit or a problem, we can identify it by measuring intake and output. Maybe the patient came in because they were dehydrated because they went to Cancun on spring break and they chewed on the ice at the bar. Not saying that happened to me. I'm not saying that happened to me, but let's say it happened to me, right? So they get violent diarrhea and vomiting and they come back and they're so dehydrated that even the fluids they're taking in, they're not putting any urine out. Well, we would have a history on that patient and we would know, oh, maybe they were so horribly dehydrated that now they're catching up with the fluids. But at some point, they're going to catch up. So we do intake and output to monitor patients' fluid balance in their body. And it's very important. So it's always two different numbers. So I want you to look at your screen or my screen, and I want you to tell me what is included in the intake in this screen right here. What would I include in the intake? Just looking at what you're reading right here.
The IV that's infusing.
Okay, IV infusing at 100 milliliters. What's HR?
Hour.
Okay, so that patient has got an IV going in their vein, going at 100 milliliters every hour. They're getting 100 milliliters. Okay, what else?
Coffee, emesis.
Coffee, I
MSC.
want intake.
Oh, intake. Oh,
Yeah.
sorry. Water, ginger ale.
We got water.
That's
I
it.
got water. All right. That looks about good. What's included in the output?
Vomited.
They vomited
And all those voids.
and all those voids. Voids mean what? Urinating. So yeah, guess what? In nursing school, you got to learn the terminology. This is part of it. So I don't know about you, but I don't do one giant void or urination for the whole 24 hours of my day. So I would anticipate that my patient might urinate in the morning, maybe a couple hours after breakfast, maybe around lunch. I don't know, depending on what they're putting in or we're putting in their body. And then what's wrong? But they had a bowel movement. Do I count that?
No,
Why?
because the body pulled the moisture from that stool. It's the point of the intestine.
So it's formed.
Yeah.
How am I going to measure it? It's not going to give me a liquid amount, right? So it's formed. And 1 cup of rice, it's a solid. 4-ounce piece of chicken, it's a solid. So it's not part of intake. So that brings me to the question. This is a great example of what an intake and output question may look like if it were on your exam. So the question asks, what was the total intake and output during your 8-hour shift? So I want to just start with the IV fluid first. For the 8-hour shift, you said the IV fluid was part of the intake. What would you write? What's the first thing you would write about the IV fluid? How much are you going to write on the intake and output form?
Multiply by 8.
2,400.
Okay, I heard 2 different answers, so let's look at it.
I don't know because we multiply 100 times the 300.
It's 100 milliliters an hour. So every hour they're getting 100 milliliters. And I just asked you to solve for what?
For 8
Milliliters.
hours.
8-hour shift.
Oh, did you? Oh, you did.
Did you? Yes. I did.
800.
So what's my answer? I have 800 milliliters just in IV fluids. So one of the biggest challenges you're going to have when you're in this nursing program, not just in calculations, is you've got to read these questions, because I can promise you there's no patient laying around that's going to give you all the answers you need to get to the solution or the answer that you need. All right. So yes, this said for 8-hour shift, so let's just work on the intake. All right. But I just wanted to show you. So 1.5 cups coffee, and then they vomited 50 milliliters. So the output is usually pretty cut and dry, right? A lot of times it'll be in milliliters because that's how we measure it in the hospital or acute care setting. So the output is pretty cut and dry. So what could somebody tell me real quick, what would you document as the output on this patient? I want to jump over to output.
1,375.
What are you, a memorizing blinking calculator? That's wonderful. Let's look.
Well, 600
She's
and
like,
400's 1,000.
all right, well, I'm going to start simple because I don't got that power. All right, so we have 50 milliliters emesis. I like to cross off what I use, by the way, because I ain't losing points. All right, and
It'd
then,
be 1425.
oh, all right, well, I'm going to do the math. I ain't trusting nobody. All right, 375. I use that one. 600 milliliters. I use that one. 400 milliliters. I use that one. And that is all my output. I will triple, quadruple check it, and then I will get my calculator. And then I will do 50 plus 375 plus 600 plus 400. And that equals 1425. So if I wrote on the answer line output 1425, would I get that right?
No,
Why not?
because you didn't.
Milliliters.
To label it.
Yeah, 1425 what? I need to know it's in milliliters. All right, so I just want to do a quick review with the INO, because what we're going to do next is about dimensional analysis, and you'll use it in your intake and output. All right, so we already solved for the output. And one of the bigger questions I receive all the time is, well, what if I get the output right and I get the input wrong? Do I get any partial credit? No. You know why? Because I said so. No, the reason why the reason why we don't give partial credit because intake and output, the intake is just as important as the output. If you don't have an accurate number in, you're not going to have an accurate plan of care for your patient. So input and output, it's everything is very detailed. We have to have the right information to treat the patient. All right. So it's not to torture you. If you know me, maybe. No, it's not to torture you. But we have to have all the information and it has to be correct and accurate for patient safety. All right. So that I wanted to just, you should have seen this in the videos. It should not be all new information. So I want to talk to you about what dimensional analysis is. I didn't learn dimensional analysis when I went to nursing school, but when they asked me to teach the course and they said, we teach using dimensional analysis, I said, what? So I had to relearn it, or I had to learn it just to teach it. And I do find it easier for me to use. And evidence, some of the best evidence-based practice does say it's the most accurate way to solve for medication administration. So it's basically 5 steps that you can do. And I'm going to show you the steps and how I use them. There is no way that you need to do this on the actual exam, the steps that I'm going to show you, but it helped me to master how to do it. So basically when you do dimensional analysis, we're looking for a given quantity. That's information in the question, basically. What are they asking for? The wanted quantity. And then what's the pathway to get there? How are we going to get there to the answer? All right. And that usually happens between what is given, the information given to us, and what do they want? What do you want from me? All right. So this is where the equivalents come in that you've memorized. This is why the equivalents are so important. And then once you have the equivalents set up, which I'm going to show you how, then you learn to cross off diagonally because we use everything in fractions, and then we solve, multiply, and then divide. So it's much easier if I just show you. All right. And there's a little disclaimer here. Never round your answers until the very end of the problem. And I'll show you in live person. Okay. So here's the very first question. Now in the intake and output above, there was something we selected that said the patient drank 1.5 cups water. Because when you're working in the hospital or in a nursing home or wherever you're working or in home care, the patient has a cup and they drink 1.5 cups. And that's what you would document, right? But in acute care, we have to know in milliliters. 1.5 cups is not milliliters, right? So when you read this question, the patient drank 1.5 cups water. How many milliliters will you add to the intake and output? So what is the given information in this question?
1.5 cup.
Yeah, 1.5 cups. And what is my wanted?
Milliliters.
I want to know how many milliliters 1.5 cups are. So what's my unit path? And my unit path is cups to milliliters, right? And this is the part I'm telling you, you don't need to show me on the exam. This is just a part to practice. I have to convert cups to milliliter. Is there a conversion that I memorized in my equivalent paper that tells me how many milliliters are in a cup?
240.
1 cup is equal to 240 milliliters. Okay, fantastic. Well, now what do I do with it? Well, now we start setting up fractions and we start with the given. So my very first fraction, what's the top number called? Do you guys know? Because I say it a lot in class. Numerator. And the bottom is the denominator. So how do I write 1.5 cups? Can I write 1.5 like this? Or do I need to do something with that 1.5? Do I have to change that fraction?
The 3/2.
Yeah, so I can make 1.5 3/2, and I'm not going to teach you basic fractions in math, but I'm going to just show you, I'm going to say it out loud while I'm doing it. So basically we change this fraction to a simple fraction. 2 times 1 plus 1 equals 3/2. And then I want to make this a decimal. You can do fractions, but I'm going to make it more of a decimal. What's 2 divided into 3? Put number 3 in my calculator, divide by the 2. What's my answer in a decimal? 1.5. So I like to work with decimals and fractions, but I always try to lower it down to a decimal. So 1.5 cups is 1.5 cups. And there's my first fraction. 1.5 cups over 1. So what's the rules about crossing off information in a fraction? Do you all remember?
They have to be opposite.
They have to be the same information, basically. So what's my wanted?
mLs.
Milliliters. Notice I put it in the numerator. Numerator. Okay. So the only thing I need at the end of my problem is the unit of measure milliliters. So how do I get rid of this word cup?
Put cups in the denominator on the other side.
I take my equivalent and I put it in my problem. And the way I put it in my problem matters. To cross off the word cups, I need cups down here in the denominator. And I just said 1 cup is 240 milliliters. When I put the cups in the denominator, I can cross off the word cup here and I can cross off the word cup here. What's left?
Milliliters.
Just milliliters. And that's exactly what I need. Only milliliters. Nothing in the denominator, just milliliters on top. So now it's just math. Now I'm going to say 1.5 times 240 is
360.
360. 360 what?
Milliliters.
Milliliters. So the answer to this question, if it were standalone question or part of a question of an intake and output, is 1.5 cups is equal to 360 milliliters.
So
Right?
will that be considered all right, or we still have to show all the steps how we got to 360?
I just need to know how some form of this. I'm okay if you
Okay.
write 1.5 cups equals 360 milliliters. Even if you wrote 1.5 cups times 240 equals 360. I just got to see something.
So 1.5 cup equals 360 milliliters is enough.
No, I want to see why. What did you multiply it by?
So can it be 240 plus
Yeah.
240 divided by 2?
Yeah.
Okay.
Yep. So here, what's the given? This question says convert 1 2/5 pints to milliliters. This was part of that intake and output. So my given is what?
1 and 2
Right.
fifths would
1
be the
2/5 pints.
pints would be the
My wanted, it says convert it to milliliters. That's my wanted. My path is pints to milliliters. Okay, great. What's the conversion I should have memorized?
240 mLs with 1 pint.
Is it?
480.
480 milliliters. Very good. So now let's put it in my problem. So 1 2/5 is equal to 7/5 is equal to 1.4 pints. I put it over 1. I don't like blank spaces. It makes me crazy. And then my wanted is milliliters. I put it in the numerator position. Look at me go. So now how do I get rid of pints? I'm going to use my conversion. And I have to put 1 pint down here and 480 milliliters on top. This crosses off my pints, leaves me with my milliliters. And now 1.4 times 480 is?
Russia, I have a question.
1.4 times 480 is 672 milliliters. So remember, this is just working off of that intake and output. What's your question?
Why do they put sometimes for the point they put 500?
Who?
I saw it in the book, I think so.
No, your equivalent page, you have to memorize the RCC equivalents, not anywhere you work. You only have
Okay.
to memorize our equivalents, and that was that one page we gave you. So one
Yeah, okay.
pint is 480. Now, I know other facilities may say 1 pint is 500. I know when I worked in home care, 1 cup for one patient was 120. 1 cup in the hospital was 240. So it's going to be different wherever you work. You follow that hospital policies and procedures. But when you take exams at RCC, you only memorize what we're telling you, okay? Because that's what we're testing you on. So if somebody else has 500, it's not what I'm going to test you on. So be very, very careful for anybody that has experience. It's a trap you guys get sucked into all the time. All right, so I want you to look at this one. What's my given?
8 ounces.
8 ounces. My wanted?
Milliliters.
My path is ounce to milliliters. What's the conversion?
30 milliliter. Oh,
1 ounce is 30 milliliters. Beautiful. So now I'm going to set up. So this patient had 8 ounces of juice, but I need it in milliliters because I'm putting it on my intake and output, right? So I start my fraction. 8 ounces over 1. I should probably make that a smaller ounce because I don't want to mistake that for 80. 8 ounces. And I'm solving my wanted as milliliters in my numerator. Oops, numerator. So now I need to say 1 ounce is 30 milliliters. Gets rid of my ounces. I have milliliters left. And now it's just math. So 8 times 30 is
240.
240 milliliters. So the answer to this one is 240 milliliters. Somebody had a question?
Yes, please. So we have to put units at in the final answer. Do we have to use units during every, every step of the way? Like, do we have to show the units we used every step of
I
the
can
way?
tell you if you were in my live, if you were in my class, it only helps me identify if you've made an error and you want to come and find out why you did something, you had an error on an exam. That's one way I can see what the error was. Sometimes it will help. On this exam, you can write whatever you want. I just got to know that you're doing the work. I'll be able to tell because I know what the question is. But yes, in the final answer, you have to have the unit of measure. Yes. I don't care if you have it down here, but that's up to you.
Thank you.
Sure.
I also had a question. I wanted to know where the RCC conversion chart thing is.
You
and where
received it via email?
I see like one that has like a bunch of docs together. It shows like webinar videos, weekly PowerPoints, and weekly practice
No.
sheets.
You should have received the email for the Calc Challenge. It was all included into that. When you got the original email,
Oh, okay. Let me check
there
that
was
one.
an equivalent. And also there's links to like flashcards and stuff to help you memorize them.
Okay, thank you.
Sure. All right. And then half a quart. Half a quart. Wanted is milliliters. The path is quart to milliliters. So I'm going to go quick on this one. So what's the conversion for quart?
960.
There you go. 1 quart is 960 milliliters. So 2 pints is 1 quart. And that's one way you do it. So how do I write half in decimal?
0.5.
0.5 quarts over 1. 1 quart is 960 milliliters. I'm solving for milliliters. And it's about crossing off my unwanted units, only having my wanted. And then it's just math. So when I do the quart, 0.5 quarts to 0.5 times 960, it'll give me 480 milliliters. So when you have all this information in your intake and output, kind of like you did with your output prior, the intake, you're just going to add everything in together related to milliliters on your intake and output, and that would be your final answer for intake. So 800 times 360 times 627 times 240, that would be tallied up and that would be your intake answer. So remember, intake and output, always 2 answers, one for in, one for out, and it's got to be in milliliters. All right. Now you see how long one intake can take you. So if you want it to be strategic and save it for last, you could do that if you think that's what's going to take you the longest time. Okay. Just about strategy because your exams are timed. You only get 1 hour. Okay. All right. So that is basically what dimensional analysis is. It's having this 5 steps to solving problems. Now, this one, pretty cut and dry, but medications, when we give medications to patients, some of them are administered based on the patient's weight. So we have to be able to convert between pounds and kilograms. So I want you to look at this one and tell me, what is the given in this question?
115 pounds.
Okay, 100, oops. 115 pounds. And what's the wanted?
Kilograms.
All right, so kg is kilograms, so I got to go pounds to kilograms. And what's the conversion?
2.2.
2.2 pounds.
To what?
1
So 1
pound.
kilogram.
One
1
kilogram.
kilogram is 2.2 pounds. So those of you who are clinically or even visited somebody in the hospital, you look on their whiteboard, that board that's by their bed, it'll say their weight. If it does say their weight, they might be getting a medication based on their weight, but we should put every patient's weight on the whiteboard in kilograms, because if there's an emergency and we have to use certain resuscitation medications, they are all weight based. So that's why your managers are like, please put the weights on the whiteboards, because we need that. Heaven forbid an emergency, and some meds just they take normally are weight based. All right. So yes, the conversion is 1 kilogram equals 2.2 pounds. One of the biggest errors I see all the time is people reverse this and say 2.2 kilograms is 1 pound. Please be careful. It's 1 kilogram is 2.2 pounds. So how do I do this problem? What's my given? I start with the given, put it in as a fraction. All right, numerator, denominator. My wanted is kilograms. Keep it a fraction, numerator. That just means I need kilograms in the top position. So that tells me, it helps me focus on how to set up my equations. So how do I get rid of the word pounds and get to kilograms?
1 kilogram over 2.2
You got
pounds.
it. 1 kilogram over 2.2 pounds. I'm going to put the conversion in my problem, but I set it up so I get rid of all the unwanted units and I'm left with the wanted. Beautiful. So 115 times nothing or 1 is 115, and 1 times 2.2 is 2.2. And then I divide, and when I divide 2.2 into 115, it's going to tell me on my calculator 52.27272767. No, I'm kidding. All right. So my calculator is going to give me this, and this is the rounding. This is where rounding comes in. Does anybody know what the final answer is?
52.3.
All right, I heard 52.3.
52.
52.
52 because it's greater than 10, so you
All
round to 10.
righty, I got you. 52 what?
Kilograms.
Kilograms.
Kilogram.
Kilograms. Yes, you are right. 52 kilograms, because any number greater than 10, that's greater than 10, we round to the whole number. So how do I make my decision? Do I make this 53 or keep it at 52? I look to the number to the right. If that number's not 5 and higher, I'm keeping it 52. Okay? So the answer is 52 kilograms. Now let's say on the exam you wrote 52.3 kilograms. What would happen? I'd come to your house and I'm saying, what did you do? No. What would happen is I would just say, all right, you know what? You're going to lose 1 point for that. It's just a rounding error. Let's not lose our minds. Okay? So that's what I was talking about in the beginning about the rounding rules. So let's do another one. I'm going to not help you. I want you to solve for this. And this, so you could please put it in the chat directed to me. And I'll give you a moment to solve. Yes, you had a question?
So for every thing we can't do decimals at the end, like for milliliters too, or is it just
No, not everything. There are rounding rules. So you definitely have to become familiar with the rounding rules, but they are, as I said, on the front page of your exam. But you should be familiar. Any number between 1 and 10, we round to the tenths. Any number less than 1, we round to the hundredths. Any number greater than 10, we round to the whole number. If we're using an IV pump machine, we follow full rounding rules. If you have a capsule, you can't split it. So there's so many little things just to pass meds in nursing that you have to be familiar with. But when in doubt, if you're not sure, if I see your work and I know you made a rounding error, I can at least dock you the 1 point instead of taking all your points away. Make sense? Cool.
Now, how would that work? Because you were saying that answer has to be in the answer line, so that would be something that you would be kind of I guess, like looking for in the work a little bit more.
Yeah, I
so
would look
it
in the
still
work.
Be okay
So
that.
yeah, so if I looked in your work and I saw all of this, let's say, right? But on the answer line you wrote 50, let's say on the answer line you wrote 53 kilograms. But I saw here you just made a rounding error, I would only take away 1 point. That's why showing the work is really important, because I will know if I could tell you right away, like if you take an exam for me, like in my regular class, and you make an error and you come and say, I don't understand what I did wrong. And then a lot of times it's somebody flipped the conversion wrong. I can show you right away and you're like, oh. So yeah, I will look at your work to make sure I'm giving you a very objective point. All the points are minus 1 point, or you lose all 5 for sure. That's why it's so worth showing your work. So what did everybody get for 44 kilograms to pounds? I see a lot of different answers. So we're going to do this one together. All right, no worries. So let's do it. So the given is 44 kilograms. The wanted is pounds. Oops. My path is kilograms to pounds. And like I said earlier, you don't have to do all this part on your exam. This is just as I teach you to do it. It just helps you stay focused. So I need a conversion. I need to know that 1 kilogram is 2.2 pounds. So we start our problems with the given. The given in this question is 44 kilograms, and I put it over 1. My wanted is pounds. Oops. Oops. My wanted is pounds. I'm going to put that over 1. I don't like blank spaces, like I said. So this is the numerator. I need the word pounds in the numerator position. So that means I got to get rid of kilogram. So how am I going to get rid of kilogram? I'm going to put my conversion in there, and I'm going to set it up so the kilogram is diagonal. So 1 kilogram is 2.2 pounds. I cross off my kilograms, and now I'm left with the only unit of measure, pounds, in the numerator. So now I just do math. So 1 times 1 is 1, and 44 times 2.2 is 96.8 on my calculator. Do we agree? 44 times 2.2 equals 96.8.
Yes,
What's my final answer?
97.
97. All right. So it's greater than 10. I have to make a decision. Keep it 96 or make it 97. I look to the right. I look to the immediate right. Is that 5 and higher? And it is. If that is 5 and higher, I'm moving this bad boy up. So my answer is 97 pounds. This is a 97-pound patient. All right. So 44 kilograms equals 97 pounds. Yay. Brilliant. All right. You want to try this one? Let's do this one together. This one's pretty brutal. I can't help myself sometimes. So what's the given? This is where you have to be careful. Now, are you going to have a problem like this in the real world practicing as kooky as these numbers? No. But what I'm going to do is make you focus and concentrate enough so you don't make an error that harms a patient. Now, I'm going to teach you that. So 0.04567 grams. My wanted is micrograms. So what's my unit path? I have to go grams to milligrams to micrograms. Come on. Yes, yes, this is great. So how am I going to do that? What are all these conversions? Somebody tell me the conversions.
1,000 milligrams is a gram.
1 gram is 1,000 milligrams. Okay. What else do I
Microgram is
need?
1,000. Another 1,000.
I need another 1,000. So yes, 1 milligram is equal to 1,000 micrograms. The biggest error I see with questions from grams to micrograms, they go 1 gram is equal to 1,000 micrograms. They basically skip 1,000. And that's not right. And the patient gets underdosed. So let's do it. The given 0.04567 grams over 1. So out of all of this, I know I'm solving for micrograms over 1. I know my unit path. So how do I get rid of this gram? What do I put here?
1,000 over
1,000 milligrams over.
Yes, my first conversion right in there. So 1 gram is 1,000 milligrams. Beautiful. Cross it off, and I've used it. So now how do I get rid of milligrams? My next conversion. Put it right back. So it'll be what? To get rid of milligrams, 1 milligram goes down in the denominator, and 1,000 micrograms goes in the numerator. And when I look at it, everything is crossed off. The grams is gone, the milligrams is gone. All that's left is a microgram, and it's in the numerator position. That's how I know my setup is correct. So now it's just math. So what's the answer? I gotta use my calculator. I don't remember.
45,670.
Oops, 45670 micrograms. Boom. Now I know a lot of people will be like, I can just do this. 1, 2, 3, 1, 2, 3. Go for it. Show me your work. But don't come to me crying when you get it wrong. I really push trying to get that dimensional analysis down pat, because you'll see when we finish how far we go 10 fractions in. We're doing cardiac drips. Okay. All right. So let's talk about insulin. Insulin is a hormone used for people who struggle with diabetes.
Also, I have a question.
Sure.
The one we just did, can I do it? Can I say, okay, I want to do it like step by step? Like, okay, I do first and the second step, or just do like you did?
As long as I see your work.
Yeah.
I know people learn to do it different ways. But I encourage you to start doing dimensional analysis as soon as possible, because it doesn't go away your entire nursing program. But hey, do what you got to do to get through the exam, and hopefully you don't make an error.
All right. All right.
All
Thank
right.
you.
As long as I see the work. All
Okay.
right. So insulin, I want you to be familiar with insulin. You're going to learn about it in school, obviously. It is a hormone. People who have diabetes, it could be type 1 diabetic. Their pancreas doesn't produce the insulin, or they develop type 2 diabetes due to insulin resistance. Whatever the reason is, if they need to get insulin to bring their sugar down, the nurses are the ones that give it. And some disorders and some medications can cause the insulins to go up. So you have to be familiar with how to read insulin orders. And then what is the question asking you? So a standard insulin order is something like this that you see on your screen. So the doctor has ordered Humulin N, it's just a type of insulin, 4 units mixed with Humulin R, 4 units. What does AC mean?
Before
Before
meal.
meals, right?
Before meals.
All right, so this patient needs this insulin before their meals. And then you'll also learn, before you give anybody any insulin, what do you check? Their blood sugar level.
Sugar.
Yes, because insulin drops the sugar. So if you don't check it before you give it, and your patient dies because their blood sugar they have no blood sugar in their body, it's because you didn't check it. You're going to lose your license. So what is the total amount of insulin the patient received? Let's say this was for breakfast. How would you answer this question?
8 units.
Yeah, it's not a trick. They're going to get 4 units of N. And by the way, insulin is only given in units, and it requires a special insulin syringe. So they're going to get Humulin N 4 units and Humulin R 4 units. So the question says, what's the total amount the patient's going to get? The answer is 8 units. It's not a trick. Okay? The errors come when people don't read the questions. So what's the answer to this one? Well, first, you know what AC means. What does HS mean?
At bedtime.
At bedtime. So HS means hour of sleep. So that is at bedtime. So this patient is going to get insulin before their meals and at bedtime. Awesome. What's the answer to this question?
It's 11.
11. It's not a trick. I swear. They're going to get 8 units of N and 3 units, of R. 8 and 3 is 11 units. That's the total amount. So those are standard type of orders. But they also have coverage orders. If they're usually in the acute care setting, they will have what's called a coverage order. So they'll have a standard order and a coverage order. So a coverage order is just additional regular insulin or rapid acting insulin. And this coverage order is based only on the actual blood sugar that we take from the patient right before giving the medicine. So if there is a coverage order, you will have parameters. There will be parameters. So that means at 12 o'clock, you go in and the patient's finger stick, which means they poke their finger, take their blood, is 149. How much insulin will the nurse administer to this patient? What's the answer to this one?
No insulin.
All right. The sugar was 149. Where does 149 fall? That's less than 150. The patient gets no insulin. All right. What about this one?
And
10 units.
Right. At 7 a.m., before breakfast, perhaps, they did a finger stick, pricked the blood. It was 348. Where does that fall? The patient will get 10 units of insulin. Now let's put it all together. What's your answer?
Just 6 units.
Okay.
It's 30 units.
Oh, I got different answers.
I got 25.
What?
13 plus. Oh,
Okay.
sorry. Yeah, no,
That's
I'm
okay.
wrong.
That's okay. That's why we're here. So this is a typical kind of order for insulin. So the patient needs to receive Humulin N 13 units mixed with Humulin R 11 units before meals and at bedtime. In addition, they need to have coverage. So you do their finger stick and it was 202. 202 falls right here. What is the total amount of insulin the patient will receive?
30.
Got it now? They're going to get 13 units, 11 units, and because their sugar was 202, they're going to get additional 6. And that gives you a total of 13,
30.
30 units. I'm not losing 5 points on this kind of question now. If that's on that test, I swear I'm coming to your house. I'm coming to your house. All right. So read your questions. Look at them. You're going to have a paper in front of you. It's a paper exam. Circle it. Read it and circle it. All right. Because you have to be this detailed. Because let's say you did give the patient only 6 units. They would have missed out on 14 units. No. 24, I don't even know. 24 units. They would have been underdosed. So that's how detailed and focused you must be when you give your meds. Beautiful. Give me this.
Also, that question could have been worded a little bit different, where it could have said, what is the total amount at that time that the patient will receive?
Well, it did say at 2100, so I don't know how much.
Well, but that's an assumption. At 2100, just the glucose was at that time.
No,
but
you're thinking into it. You're doing the typical overthink. The typical overthinking it. All right. What is the total amount of insulin based on this? That's it. Don't overthink it. You're going to don't. Are you in 118?
Yeah.
Oh, we're going to go. We're going to have fun. We're going to have a good time. All right. Now do this one. Don't overthink it. What's in front of you? All right. Read it and tell me what the answer is.
Twenty-two.
Okay. Everybody agree? So 7 units plus 5 units, Then the sugar was 303. 303 falls right here. So it's 7, 5, and 10. Right? 7, 8, 9, 10, 11, 12, 22 units. All right? Because at 17:30, we did a blood glucose because we're giving these meds before meals and at bedtime. I'm not going to trick you and see if you're going to read, is that really the mealtime? That's not what, nobody will do that, I promise you. It's just about you reading the question. All right. Now, when you are working as a nurse, yeah, you have to make sure it is actually where you work before their meal. You have to know when the meals are delivered on your unit. And you have to know what's considered bedtime where you work. But for here, when you're learning it, it's just cut and dry. It's bedtime, 17:30, everybody's going to bed or having dinner, whatever it is. All right. So please don't fall for it. Don't overthink it. All right. Let's talk about the feeding. Okay. So now when we talk about feeding, it's basically called enteral feeding. And this is a common type of order. Now, nowadays, there's a lot of standardized formulas. So we're only going to ever ask you to, and let me tell you about formulas really quick. If you didn't watch the PowerPoint, I really do encourage you to watch it. So we give feedings for patients through a tube that's in their stomach or it's in their intestines because they can't swallow safely. Something has happened, usually a stroke. They've had a stroke and they can't swallow without aspirating and getting pneumonia. So what happens is because they can't eat safely, they put a tube in them so they can get nutrition and calories and protein and fats and all that good stuff. And in addition, we can give their medications through that feeding tube as well. So a lot of times when patients start with a new feeding, we have to dilute it because it's a very rich, concentrated formula. So we have to dilute it. Now, in the past, we used to have to dilute it by like 20%, 30%. It was so crazy in the past, but now the formulas are much more advanced and they're better tolerated. So usually, if anything, we just dilute by half. But it's still, people do struggle with how to dilute things. So I'm going to show you the simplest way to do it since it's only by half. Now, I know the PowerPoint reviews it a different way, but I promise you, you will appreciate this way much better. So the doctor orders half strength formula. Half strength formula through a tube. Okay. They go into the pantry, let's say, or the kitchen on the nursing unit, and in there is a can. And if you look at this can, it says 250 milliliters. There's a can that has 250 milliliters of formula. All right. How much water will the nurse add to the can to dilute it by half? That's what this is asking you. All right. But I'm writing it this way, and I write the other orders the way they are written because that's how doctors write the orders. So you have to start becoming familiar with it. Okay. So the doctor wants this diluted by half. So the can has 250 milliliters in it. How much water do you think I need to add to dilute it by half?
250.
250
Yeah, you add equal parts water. So it's not a trick question. The actual answer is to make this 250 milliliter can half strength diluted, I have to add the same amount of water, 250 milliliters. Now I put this picture of the bag because a lot of people are like, how do you add that to that little can? We don't. We put the formula into the bag. All right. We actually put it in the bag and then we add the water to the bag. So we add equal parts to dilute it. Now, this question just wants to know how much water we add. So what's the answer to this one? 50%, by the way, is still half, all right? So if you see 50% or half, it still means by half, okay? So how much water will the nurse add to a can that has 350 milliliters of formula to make it 50% diluted?
350 ml.
Yeah. So you're going to add 350 ml. So you're adding 350 mLs to dilute it of water, H2O. What if I asked you what's the total amount the patient received?
700.
Say that again?
700 ml.
Yes. So remember, you walked in and you grabbed a can that had 350 milliliters of food, feeding. You had to add 350 milliliters of water. And the question said, what was the total volume? Because where am I putting this information? on the intake and output. So I added water to dilute it. So what am I going to add to the actual intake and output is 700 milliliters because the total volume was the formula plus the water is 700 milliliters. Remember, intake and output is always in milliliters. So what do you think is going to happen? That's right. Now it's a 10-ounce can. So I'm going to show you a way to do it. The PA ordered 50% strength enteral feeding. Water is added to a 10-ounce can of Lucerna. It's a type of feeding. How much water must be added to that 10-ounce can? So you go into the pantry and there's 10 ounces of formula. How much water do I need to add to it to dilute it by 50?
10 ounces.
10 ounces. Okay. 10 ounces of H2O. But what is the wanted? What do I need to solve for?
Milliliters.
Right on. So 10 ounces of water. And what's the conversion ounces to milliliter?
30 and for 1.
1 ounce is 30 milliliters because I want milliliters because it's part of my intake and output. I cross off my ounces. I have milliliters in my numerator. Now it's just math. So what is the answer? How many milliliters of water am I going to add to this can?
300 milliliters.
300 milliliters. Yes. What's the total volume you're going to put on the intake and output?
600 milliliters.
600, because if this 10-ounce water is 300 milliliters, that means this 10 ounces of formula is also 300 milliliters. So the total volume, if I asked you that, is 600 milliliters. So your feeding questions will either only ask you total volume, meaning formula and water, or just water. You just have to make sure you read the question, okay? So I'm going to let you do this one and tell me what the answer is. All right, let's read this here. The doctor orders half strength, longevity type of feeding. And when you go into the pantry, or maybe dietary delivers an 8-ounce can of formula called longevity. What's the total volume of the feeding the patient will receive? But what do I have to do first? I have to dilute it. So basically, you can't solve for total volume without solving for how much water you're going to add, because the order said half strength. So to dilute it by half, I add 8 ounces of water. So 8 ounces of water, 8 ounces of formula. You could do it different ways. 8 and 8 is 16 ounces. Looking familiar? Looking like a dimensional analysis kind of question? So 16 times, oops. So the final answer is the total volume is 480 milliliters. Beautiful. 5 points. It'll be great. You love it. All right. What about this one? Yes, good. You got it. I'm looking at the answers. I don't know why it's. Oh, Nicole, yes, it asks. Yeah, you have to know. It's not going to tell you. You have to know that enteral feedings, you have to solve for milliliters because it's part of intake and output. So yes, you must be familiar with all of that. For sure. Yes. So everybody that answered 360 milliliters, you're correct. And it was a great question. Someone said, wait a minute, it doesn't tell you what to solve for. No, you have to know that anything enteral feeding is going in the body, and we have to know what it is in milliliters so we can add it to the intake and output. So we always solve for this in milliliters automatically. So 6 ounces, you can solve 6 ounces alone. and then multiply it by 2, or you can solve for 12 ounces because remember, you walked in the pantry, there was a 6-ounce can of formula. You have to add 6 ounces of water, and that's 12 ounces, and 12 ounces times 30 milliliters over 1. That will give you 360 milliliters total volume. That's what you're going to put on your intake. All right. Woo! Okay. Let's keep going. You just did 3 weeks. It's doing good. All right. So now let's talk about some pills, capsules, and tablets. All right. So we're still using dimensional analysis. Hold on one second. Okay. All right. So the prescriber orders 375 milligrams of a drug. You have on hand a bottle labeled 250 milligrams per capsule. So when you see something that says on hand, it's either delivered by pharmacy, or it's in your med drawer, or it's in the patient's cabinet if you're working home care. So when you say on hand, it's what's available to you, what's available for you to use. So what is the given in this question?
200 milligrams per capsule.
Well, that's actually it's not, but that's I'm glad you mentioned that. I wanted to say the given in these kind of questions is the doctor's order. All right. So what is the doctor's order?
375.
The doctor has ordered 375 milligrams of a drug. All right. What is wanted? What am I solving for?
Number of capsules to give.
Capsules, because what am I going to give the patient? It comes as a capsule. So I have to solve for what I have. I can't solve for a tablet because it's not a tablet. It's an actual capsule. All right. So is there a unit path? Well, no, because the strength is in the same unit of measure, milligrams. So I don't need a unit path and I don't need any conversions. But now I need to know what I have on hand, or they call it available. And then what somebody said it, what you have is there's 250 milligrams for every 1 capsule. So it's kind of like you get a bottle of Tylenol, and on the front of the bottle it says 500 milligrams per tablet. This question is telling you it's 250 milligrams per capsule. And that's what's on hand. All right. So what's the rule with capsules? Does anybody know the rounding rule for capsules?
Wouldn't you have to round to the nearest whole number?
Yes. Why?
Because you
Because we
can't
can't
give
split
more
them.
than
You can't
crush it
split
or
a
anything.
capsule. You cannot split a capsule. Now, I know if you're a practicing LPN, I know what you do. I know what you do. You do not do that at RCC or the NCLEX exam. Capsules are made to not be broken open, okay? I know what you do. I don't want to hear it. All right. But the rounding rules, what you need to know for RCC and for the NCLEX is these cannot be broken. The final answer has to be rounded to a whole number, okay? So I start with my given, 375 milligrams over 1. My wanted is capsules because that's what's available to me. It's not milliliters. It's not ounces. It's not a tablet. What I have is a capsule. So now how do I get rid of milligram and get capsule in my numerator? What do I use?
You use 1 capsule over 250 milligrams.
Yes, I use what's available to me. 1 capsule is 250 milligrams. So I cross off my milligrams and I'm left with my capsule. Boom. So now 375 times 1 is 375 and 250 times 1 is 250. And now I divide. When I divide, what do I get on my calculator? Oops.
1.5.
We got a problem then, don't we? I can't give 1.5 capsules, can I? I can't break it. So what's the final answer?
2.
2 capsules.
2. Yes. All right. So if I have to
2
round to a
capsules.
whole number, yeah, I look to the right. It's 5 and up. I round this number up. So the final answer is 2 capsules, or you can write 2 caps. All right. So if you accidentally forget that rule and you put 1.5 capsules and I see your work, I will only take away 1 point and drive to your house. That's all. All right. That I just wanted to review the capsules with you. You should have seen that already. All right. So a scored tablet. So some tablets have a little perforation in them right here. They can look like that, or they can look like this one. So this one can be broken in half. You see that little scored part? That means we can snap it in half. So that will affect your final answer. And you have to be familiar with this, okay? This is very common. So when you look at this question, my given is what? I want you to really read this. I said the given is the doctor's order. So which one is the doctor's
1500
order?
milligrams.
1,500.
1,500
Yes,
milligrams.
prepare. You got to look for the orders that say prepare, order, administer. That means that's what's ordered. So the given is 1,500 milligrams. My wanted is what? What am I solving for?
For the amount of
Tablets. That's what it comes as. A scored tablet. So I'm solving for tablets. So my given is 1,500 milligrams over 1. I'm solving, my wanted is for tablets. Fantastic. What's available?
1 gram per tablet.
Yeah. So I got 1 gram. Oops. Available is 1 gram per tablet. What's the problem with that?
You have to convert it.
Yeah. It's not really a problem. The problem is you need to identify that it has to be converted because what is ordered is not what's available, not the strength, the unit of measure. So I have to convert. Why does this? Okay. I have to convert milligrams to grams. So what's the conversion?
1 gram is 1,000 milligrams.
You got it. Oops. All right. So how do I get rid of milligrams?
You do 1 tab over 1,000 milligrams.
1 tab.
No, we do
1 gram over 1,000 milligrams.
Right on. So I've used that. That crosses off my milligrams. Now how do I get rid of grams?
1 tab per milligram.
1 tab is 1 gram. We're 3 fractions in now. And now it's just math. So 1,500 times 1 is 1,500. And 1,000 times 1 is 1,000. So when I divide 1,500 by 1,000, what's my answer?
1.5 tablets.
1.5 tablets. And can I give the patient 1.5 tablets based on this scoring?
Yes.
Absolutely. So that means when I go into my patient's room with that medicine cup, I'm going to have 1 whole tablet and then 1/2 of a tablet. And that means when I give this 1.5 tablets, that equals 1,500 milligrams, what the doctor ordered. Woo! All right. Synthroid, the doctor ordered 0.75 milligrams. Wanted, it comes in a tablet. That's what I got to give. My path, well, guess what? 1 is in micrograms and 1 is in milligrams. So what's my conversion?
1 milligram is 1,000 micrograms.
You got it. And what's available? 250 micrograms per tablet. All right, I'm going to pause and I'm going to let you solve. Okay? Go ahead. All right. So if you got the answer of 3 tablets, you are correct. Good job. Yes, all right. And now remember, make sure you only write the answer in the answer line. Don't write anything extra because if you add something incorrect, I have to mark it wrong, okay? So just add the answer. That's it. Okay, so let's do this together. We start with the given, the doctor's order. 0.75 milligrams. I put that over 1. I want it as tablet over 1. Now I have to get rid of milligrams to get to the tablets. So to get rid of milligrams, so I know this and I know this, I have to use a conversion because what's available is in micrograms. So 1 milligram is 1,000 micrograms. I'm going to cross off what I'm using. And then to get rid of micrograms, I use what's available. And that's 250 micrograms per tablet. That crosses off my micrograms and that leaves tablet in the numerator, just what I need. Everything else is crossed off. Beautiful. So now it's just math. So 0.75 times 1,000 times 1 should be 750, and then 250. When I divide, the answer will be 3, and my answer on the answer line is 3 tablets, just like this. 3, not 3.0, just 3, okay? Beautiful. All right, I want you to do this one. I'm going to pause. Now remember, this tablet can be broken into quarters. Well, actually, you know what? Do I have? No, I don't have it. All right. So, no, not yet. Do this one. I'm going to pause. This basically means when it's broken in quarters, it means I can give a whole tablet. I can give a half a tablet. I can give 1 1/4 tablets. I can give just a quarter. So it means I can give many variations, which means I also give many different doses. All right, so I want you to solve this. I'm going to pause. In the interest of time. All right, so let's go over this. Majority of the answers were correct. The answer is actually half a tablet. So let's go through it real quick, and then I'm going to show you some acceptable versions of how you can write that. So from 3.2 gram scored tablets, prepare 1,600 milligrams. So the given is the order, and the order is 1,600 milligrams. So for those of you who didn't start there and you accidentally started here, you already found your error, okay? So what's wanted is a tablet because that's what I have in front of me. That's what I'm going to give my patient is a tablet. All right. I don't know about a unit path yet, and I don't know if I need conversions, but when I look at it, I have milligrams and I have grams. So what's available to me is 3.2 grams per tablet, and the tablet happens to be scored, meaning I can break it a certain way. And in this case, I can break this into quarters or 0.25 quarters. So that means each little piece is a quarter. Okay. Awesome. So 3.2 grams per tablet. So I do need a unit path. I need to go from grams to milligrams. So my conversion is 1 gram is 1,000 milligrams. Beautiful. I start with my given. 1,600 milligrams over 1. My wanted is tablet over 1. Beautiful. How do I get rid of milligrams? Well, I know my given, I know my wanted, and I know I have a conversion available to me to get rid of the milligrams. So 1 gram is 1,000 milligrams. And I write it this way so I can cross off diagonally the unit of measure. Now, how do I get rid of grams? I'm going to use what's available because it's in grams. So what do? I put 3.2 grams in the denominator and tablet in the numerator. Beautiful. When I look, everything is crossed off except the unit of measure tablet, and that's what I need in the numerator, and that's where it's located. So now it's just math. So the math, when I do it across the top, it'll be 1,600 times 1 is 1,600, and then 1,000 times 3.2 is, I gotta do the math here, 1,000 times 3.2, and that will give me 3,200. I just like to be careful. So then I put in 1,600 divided by 3,200, and that will give me 0.5 tablets. So that means I'm going to break this tablet in half and give 1/2 of this tablet. Just because it can be broken in quarters doesn't mean I have to give a dose in a quarter. So this particular available medication is going to be broken in half, and the patient will receive half a tablet, and that half a tablet will equal 1,600 milligrams. All right. So on an exam, I will accept half a tab written like this, or half a tab written like this. You will lose a point if you write it like this. Does anybody know why?
Because decimals get lost.
The decimals absolutely get lost. And what else? What could this be mistaken for?
5 tablets.
5 tablets. Right on. All right. So let's say another great example. Let's say you're working in pediatrics and the doctor says an infant needs 0.5 micrograms. He forgets the 0. You don't see the decimal. And we give 5 micrograms when the baby needed 0.5 micrograms. You've just overdosed an infant. So that's why we always put a 0 before the decimal when it's less than 1. Now, I want to talk about trailing zeros. What if the answer was 5 tablets and you wrote it like that? Or 5 milligrams, or 5 micrograms, or 5 milliliters? Why do we not put a 0 after the decimal? Because I could mistake it for 50. Okay? So there are rules surrounding zeros. I won't take off all points. I'll take off 1 point as a rounding error. But these type of errors will kill patients because that's how much of a difference in a dose it could be. All right. So, and I know people are like, why do you always say that? Kill, kill, kill. Because it's true. I don't sit there and go, I want to kill. It's so true. Okay. So I just want you to be careful. I want you to be amazing nurse. I want you to be amazing practitioners. Okay. Make your errors with me and then we'll work on it. All right. So now let's talk about reconstitution. So that was capsules and tablets. So you've already done insulin, capsules, tablets, INO. We're cruising right along. Let's move on to something called reconstitution. And by the way, these were all considered one-factor medications. You'll hear me sometimes reference that one-factor meds, or you'll see things listed in the course as one factor. When I say one factor, it means there's only one element to the doctor's order. There's just one element, usually the strength. So like for this one, the order is 0.75 milligrams. That's a one factor. So here is another one factor. Prescribed, that's the order, right? 15 milligrams of a drug. And what's available is 3,000 micrograms per milliliter. And the question says, how many milliliters will you administer? So the given is my order, 15 milligrams, and it's a one element, one factor. Wanted, this question tells you milliliters. So my unit path, I don't know what's going on yet, but I have a good understanding of it because one is available in micrograms and one is written in milligrams. So I need to go milligrams to micrograms or vice versa. So I'm going to need one of my conversions, and you guys should know this by now. 1 milligram is how many micrograms? 1,000. All right. So what is available to me? Well, maybe pharmacy sent up this vial, and the vial says, I'm a drug. And in this, there's 3,000 micrograms per every 1 milliliter. So when you see it written like this, that means 1 milliliter. All right. Some doctors will write, or some vials may say 3,000 milligrams per 1 milliliter, or it'll say it'll write per 1 milliliter, or maybe it's per 5 milliliters. My son takes Motrin. It comes 100 milligrams in 5 milliliters. I read the vial. I read the bottle. So this could be injectable. It could be an oral liquid. We don't know the drug. I don't put the names of the drugs because you're not required to know the names of the drugs, but this is what you would see. This is what it means by available. This is what's handed to you. So available is 3,000 micrograms per milliliter. All right, let's start it. We start with our given. The doctor ordered 15 milligrams over 1. I need to solve for milliliters over 1. Now, this question told me I'm solving for milliliters, but what if it didn't? Would you be able to figure that out? if this didn't say, what if it just said, what will the nurse administer? Would you be
Yes.
able to figure out that it's milliliters? And
Yes.
why?
Yes, because based off of what's available, it told
Yes.
you that it was over mLs.
That's it. You are absolutely right. What is available to you? It comes in a liquid. So what am I going to give the patient? What am I going to hand the patient? A liquid. I can't make it something that it's not. So you're going to start to learn to read these questions and really, you have to really evaluate it, because as you move through the program and you take these other exams, the questions get different and get more challenging, where you have to actually think about and process the information. All right, so now we've got our given, we know our wanted, we know our unit path. So let's start eliminating the unwanted. That's really what dimensional analysis is, eliminating what you don't want and getting to what you want and what you need to give. So how do I get rid of the word milligram? I can't use what's available because that's in micrograms. So I'm going to use my conversion. And I'm going to put 1 milligram on the bottom and 1,000 micrograms on the top. And then I'm going to cross it off. So I've used this. The only thing left is what's available. So how do I get rid of micrograms? By my available. So I'm going to write it down here. 3,000 micrograms for every 1 milliliter. And when I do that, everything's eliminated except for the milliliters. Beautiful. So now it's just math. So 15, times 1,000 times 1 is what? Does anybody know? 15 times 1,000 is 15,000. And then 3,000 times 1 is 3,000. And then when I divide, what's my answer?
5 ml.
5 mL. So if this was an oral med, what would it say? What would it say in the question to tell me that it was an oral med? Oral by mouth. Do you guys know that
PO?
abbreviation? Yes, PO. So the doctor would say, give 15 milligrams of this drug, PO, every 8 hours, or 15 milligrams IV in the vein every 6 hours. So that's how you would know what type of med and how you're going to give it. But this answer is absolutely, the nurse will give 5 milliliters. Love it. All right. Here's another example of a one factor. The doctor orders 2,000 micrograms of a medication, and there's the label. I'm going to give you a couple minutes to solve. And looking good, looking good. All right. So yes, if you put in the chat 5 milliliters, you are correct. Good job. So let's do it. The given, the doctor orders 2,000 micrograms of a med. What's wanted? Well, milliliters is telling me, but I should know that's what's available. So unit path, well, it's ordered in micrograms and available is in milligrams. So milligrams to micrograms. So you'll see a pattern. You know what I mean? We just don't know what, I mean, honestly, going to nursing school is to learn the content, of course, but it's also to prepare you for that NCLEX. I have no idea what they're going to put on that bad boy, right? So we try to, give you examples that you may see, and that's why we give you multiple level exams as you move through the program to make sure you are safe to give meds, but also so you're exposed to different ways of being asked. So 1 milligram is 1,000 micrograms, and what's available is 0.4 milligrams per 1 ml. Beautiful. Let's do this. 2,000 micrograms over 1. I'm solving for milliliters over 1. So I'm going to start getting rid of my unwanted. So 1 milligram is 1,000 micrograms. That crosses off my micrograms. Get rid of milligrams by using what's available, 0.4 milligrams in 1 ml. Gets rid of my milligrams, and that gives me exactly what I need. So I always look at my problem. I've used this, I've used this, I've used my conversion. I'm good. My setup is beautiful because milliliters is in the numerator. So another thing you can do, by the way, especially if your calculator doesn't hold a lot of numbers on it, you can cross off the same number of zeros in the numerator and the denominator. So for example, I can cross off 1, 2, 3 zeros up top and 1, 2, 3 zeros in the denominator. When I do that, it will make the numbers smaller. So now it's 2 times 1 times 1 is 2, and 1 times 0.4 is 0.4. And when I divide 2 divided by 0.4, my answer will be 5 milliliters. So the nurse will give 5 milliliters. Again, beautiful. I love it. All right. I want to talk about reconstitution. Reconstitution basically means we're going to mix the medicine on the unit ourselves. And this would all be injectable medications. So in this example, first let's find the doctor's order. Somebody tell me what the doctor's order is.
1,000,000 units.
Prepare 1 million units. Is that even a thing? It is, believe it or not, penicillin. So the doctor's order, so my given is 1 million units. Okay. And then it's telling me I have to add 8 milliliters of sterile water to a vial that has 2.1 million units in it. So believe it or not, you'll get a vial and maybe it is penicillin and it says 2.1 million units. And when you read the instructions, because every drug will require different things to mix it with, sterile water, normal saline, and it'll tell you different amounts. So that's why you have to be familiar with your nursing drug reference and where to access this information. But the question tells you, you need to add 8 milliliters, and this one would be the sterile water. Cool. So if I'm adding 8 milliliters, I'm drawing out 8 milliliters of sterile water and I'm injecting it into this vial that has powder in it. That's why it says powder. I'm going to put the liquid in here in the powder, and then that's called reconstitution. I'm mixing the med. I'm making the med to give through the IV because I can't give powder through the IV in the vein. So I have to add sterile water or whatever is prescribed to mix it with, and I will create a concentration when I do that. So by adding 8 milliliters to this vial, I have just created a concentration of 2.1 million units per 8 milliliters. You would be shocked how many people don't know how to write out millions. I don't know how to write out millions because I don't know what that money looks like. I'm kidding. All right, I really don't. So let's do the problem. So the doctor orders 1 million units, and I write units underneath these because I don't want to mistake the U for a 0. I have personally done it myself on exams. So 1 million units is the doctor's order. My wanted is milliliters because that's what I'm making, a liquid. All right. So how do I get rid of the word unit? What do I put in my next fraction?
8 mLs over 2.1 million units.
Yeah, if I'm doing all that work mixing the pharmacist meds, I'm using it in my equation. If I just mix it, I'm going to put it in my problem. So I made a concentration that I can use. So for every 8 milliliters that's in this vial that I put in, I'm going to create 2.1 million units of medicine. So it's really about, do you know how to write out the millions? And are you careful when you solve these problems? So now you can imagine the amount of zeros there are. This is where I would cross off my zeros, but you have to make sure you're crossing off the same amounts. So I'm always very careful. I start small. 1, 2, 3. 1, 2, 3. 1, 2. Sorry, 1, 2, 1, 2. All right. So I make sure I cross off the same amount in the numerator and the denominator. So now I have 10 times 8 is 80, and this is 21 times 1 is 21. When I divide, my answer will be, on my calculator, 3.80952. What's my answer? I'm going to put on my answer line.
3.8 mL.
3.8 mLs. Very good. Any number between number 1 and the number 10, 3 is between that, we round to, hold on one second, I don't want to confuse you. We round to the 10th position, one number after the decimal. So if I'm rounding to this position, I look to the right. If that number is 5 and up, I round this up, but it's not. So the answer is 3.8 milliliters. What does that mean? When I draw out the medicine, 3.8 milliliters, that means the patient will receive 1 million units of penicillin. Beautiful. All right. I want you to do this one. I'll give you a minute to solve. I actually just got the same question from a couple different students, and it's a really good question. So when you write out milliliters or any of the units of measure, the proper way to write out milliliters is lowercase m, capital L, but I will not take off points if you put lowercase m and L. All right, so it's for me, it's interchangeable as long as you're writing m and an L. Right. But yeah, the actual way to write it is lowercase m, capital L. But you will see on some of the sheets, capital M, capital L. It's because all I do is numbers and sometimes my cap blocks get stuck. So yeah, I would accept either one. Absolutely. Great question though. All right. And everybody's getting the right answer. So that's pretty awesome. So I appreciate that. So the doctor's order, what is it? It's the one that says prepare 625,000 units of a med. I put it over one because I don't want any blank spaces. And it tells me I'm solving for milliliters. Thank you very much. So I know what I need. I know where I'm going, and I know I got to mix it. And when I mix it, I make a concentration, and the concentration is 1.3 million units in 5 milliliters. And it's just about, when you're practicing, and you'll learn this as you go through the program, sometimes when we add liquid to vials, it increases the volume, but we're just teaching you the basics right now in this course. You will read it and you will know that by that point, okay? So when I set it up this way, it gets rid of units and I'm left with milliliters in the numerator position. Everything else is gone. So now I'm ready to solve. I'm going to cross off some zeros, 1, 2, 3. 1, 2, 3. So I have smaller numbers to work with. So on the denominator, 1,300 times 1 is 1,300. And 625, excuse me, times 5 is 3,125. Beautiful. So when I divide on my calculator, it will say 2.4038. So what's the rounding rules? Any number between 1 and 10. And 2 is definitely between 1 and 10. I round to the tenths, and that's this position is the tenths. All right, so I look to the right. If that number is 5 and up, I would round this 10th position up, but it is not. So my answer is 2.4 milliliters. Okay, beautiful. Good job, you guys. I love it. So those were all examples of one factor. There was one element to the doctor's order, and we wish that was always the way it is. But now we go to two-factor, and this is an example of a two-factor. So now when the doctor makes an order, he's got the strength in milligrams, and now he's adding the weight. So this part has two elements to it. So you have to understand how to write it. So the given is the order, 0.2 milligrams per every 1 kilogram of body weight. And the patient's going to get this by IV every 6 hours. And this is how orders will be written. Okay. We have what's available. Sorry. Available is 600 micrograms per 1 ml. And now we have the patient's weight. And this is a baby that weighs 6 kilograms. My wanted, how many milliliters will you give? So looking at this information, do I have a unit path that needs conversions? And I sure do. I need micrograms and milligrams again. So 1 milligram is 1,000 micrograms. And I have a weight that's in kilograms, but my order is in kilograms. So I want you to watch what I do. I start with my given. Because this is a two-factor, we have to now write it like this. 0.2 milligrams over the kilogram. That's it. That's my given. I've used it. My wanted is milliliters over 1 or nothing. So that means in this row, in the denominator row, I have to get rid of whatever's down there to make it nothing, okay? And that's why I always stress numerator and denominator, okay? So when I see problems like this, I want to get rid of everything that I don't need in the denominator. How do you think I would get rid of the kilogram in the denominator with this information in front of you? to get rid of the kilogram, I have to have kilogram here. Do we agree? Diagonal? No? Yes? Hello?
Yes, you need you need
Yes. All right.
kilograms.
Right. So what can I use in my problem?
6 kilograms.
That's right. I'm going to use the weight. The baby weighs 6 kilograms. When I use that here and I put it over 1, I can cross off the kilograms. Beautiful. So now I have to get rid of the milligram because I only want what? Milliliters. So what can I use in my problem? I've already used the kilogram. I already know what I'm solving for. What's left is the available medicine, but it's in micrograms. So what do I need to use? My conversion. So 1 milligram is 1,000 micrograms. Cross off my milligrams. Now I have micrograms, but I need milliliters. So how do I get rid of this? Now I'm going to use what's available. The pharmacy delivered something that is 600 micrograms per 1 ml. And now I'm ready to solve. Everything I don't want is crossed off, and all that it's left is milliliters. So now it's just math. So let's do it. So I'll work across the bottom. 1 times 1 times 600 is 600. 0.2, excuse me, times 6 times 1,000 is 1,200. And yes, I could have crossed off zeros, but I just didn't. All right. You can even cross off zeros at the end if you want to, but so when I divide 6 into 12, what's the answer? How many milliliters am I going to give this infant that's 1 month old? No pressure. What is the answer? What am I going to give this 13.5 pound baby? I'm going to give 2 milliliters. And when I give that 2 milliliters, that means they're getting what's prescribed. They're getting 0.2 milligrams for every 1 kilogram of body weight. So that's 2 milliliters. This is why we have to be so critical about this, because it's not even just infants and babies. If you're working in a cardiac area and you have to administer a med that slows down the patient's heart rate and you give too much and you slow it down so much that the heart stops, that's kind of important, right? So we always look for the details in our math now. Make your errors now so we can correct it so there's no problems when you graduate. So yes, the answer to this is 2 milliliters. So you have just moved into 2-factor problems. So I want you to do this one, and I'm going to give you a couple minutes to solve. All right. Looking good. You guys are doing great. All right. So so far, everyone that has submitted the answer got it correct. The answer is 7.5 milliliters for this 33-pound toddler. All right. So let's look at this. A medication is ordered to be administered. Ordered. That's the given. 1 milligram per kilogram. 1 milligram per kilogram. I got a weight. So that's 15 kilograms. And I know I can just multiply that by 2.2, and that will give me their weight, which is 33 pounds. All right, and you will get there. You'll be able to rattle this off. And the wanted, well, this one tells you it's milliliters, but we know it's milliliters because that's how it comes. So available is 2,000 micrograms, per milliliter. So you should start to feel this kind of muscle memory kicking in. And that's why I always tell people I would spend every day when I was in school practicing, writing down all my conversions until I could write them all down. Every day I would just spend, 15 minutes in the morning writing down every conversion, any of the things I had to memorize, I would just write down and challenge myself in that way. Because I'm not a student that learned easily, and you'll hear all about it in lecture, all my sad sorrows. All right. But it will really help with the muscle memory of setting up these problems just by doing them over and over again. All right. So let's see. We'll start with the given 1 milligram over kilogram because it's 2 factors, 2 parts of the order. And this is important to understand because we're moving right into three factors, so three parts of the order. So we got that, and I want to get rid of the kilograms. So I'm going to use what? The patient's weight, 15 kilograms. Put that over 1. So I've used this, and now I have milligrams, but my available is micrograms. So I'm going to do my conversion. 1 milligram is 1,000 micrograms. And then I'm going to use what's available, 2,000 micrograms per milliliter. Beautiful, because that was my wanted all along. So cross off some zeros, 1, 2, 3, 1, 2, 3, 15, and then 2. And when I divide, it will give me 7.5 milliliters. Gorgeous. I love it. All right. So those are two factor, but I also now we're going to move into IV fluids real quick. You have to know how to solve for these IV fluids, okay? Because that's all you're going to be given. No, not all, but a lot of the time your patient's going to have medications infusing through an IV pump. But for this part, I want to just I'm going to move into another part real quick. I want to go into, let me find it. Oh, there it is. Okay. So when I talk about IV fluids, it's basically we're going to give liquids to somebody, a patient, through their vein. And these are just example of what some of the IV fluids look like. So this is actually called an IV bag. So is this one. And this one, I know it's hard to see, but this one has 1,000 milliliters in it. This one has 500 milliliters in it. This one has 250 milliliters in it, and this one has 50 milliliters in it. And these are just examples of different IV bags that you'll use throughout your practice as a nurse. The larger bags are the ones that patients usually receive, like 50 milliliters every hour, or a certain volume every hour, or even maybe 300 milliliters an hour, depending on what's going on with the patient. All right. And the smaller volume bags we add medication to it. So antibiotics, steroids, we usually add antibiotics to the larger bags. There's also 100 milliliter bags, and you would find out what to mix these drugs in through the drug reference guide that you guys will be purchasing, your Davis drug guide. All right, so these are just examples of IV fluids. So how do we get this fluid out of the bag and into the person? Well, we use IV tubing. So these are examples of different IV tubing. This one, it's called IV administration set. Cool, right? But I want you to notice something on this set. Now, these are made specifically, there's little, you can't really see all the ports and stuff on them, but a lot of the tubing is made specifically for the type of IV pump. This is an IV pump, and this machine is a computer. And literally built into this machine is an entire drug library. If you work in an acute care hospital like Good Samaritan, Nyack, Westchester, these have drug libraries built into them. So these are computers. And when we use a machine like this, a pump, an IV pump, we always solve for flow rates in milliliters an hour. But guess what? Not everybody can afford these IV pumps. Specifically nursing homes and patients in home care. So what do they use? Well, they use a different type of tubing called gravity tubing. And when you don't have a computer to push your meds into your patient automatically, we do gravity where we count the drops in the chamber every minute. So you need to know the difference between what's running through a pump and what's running without a pump. So I wanted to show you a visualization of it because I don't assume anybody has any knowledge about anything nursing when you're in fundamentals. All right. Not everybody has been exposed to IV fluids. All right. So it's just like not everybody has washed a patient and seen somebody else naked that they're going to be responsible for taking care of and changing dressings and, becoming quite intimate with caring for them. So I make no assumptions when it comes to that. So I want you to get a visual idea of this. So what do? We puncture the bags. We take off this little port. We poke this little these little adapters into the IV bag, and then either we lace it through the pump or we'd have it drip the tubing just hanging and gravity taking control. Now, this one happens to have a dial. Back in the day, I'm not telling you how old I am. Be careful if you try to guess. But this one, actually, you can put it on the dial how many drops per minute. Back in the day, we had to count how many drops dripped every minute. So trust me, the advancement in technology is amazing. So there's a couple things I wanted to show you. Also, when you see this tubing, you see this here, this says 15, and this one says 10. Do you all see that? Do you all know what that means?
The number of drops per minute.
Yeah, this tells you, so these are made to work through an IV pump, but guess what? Computers fail, pumps fail. So what if you were working in a hospital and the entire drug library and the pump system stopped working, and you had to switch from a pump to gravity? You would need to know this information on the IV pump set. So this 10 means every 10 drops makes 1 milliliter. And this one means every 15 drops makes 1 milliliter. So this is something you would use to figure out how fast to run something with gravity. And these are called drop factors. So the drop factors are found on the tubing. But when I have a computer, I don't need to use the drop factor. I only need the drop factor when I have to figure out drops per minute. Okay, so I wanted to show you guys that real quick.
Is that drop factor based on the diameter of the tubing?
Yes,
It's
yes,
a
exactly, yes. Because this one will give you more drops to make a milliliter. And there's something called, did anybody memorize a drop factor that's called micro drops?
60.
Yes, very good. That is 60 drops to make a milliliter. Very good. And that one has a tiny, that's the only one with a tiny little pin inside the drip chamber. So that one gives you more bang for your buck. Usually the hardest ones to find, but it's very important for you to know that, and I'll show you. So I'm going to teach you a method I use, and hopefully you will use it. So I'm just going to talk and show you and just hear what I have to say. The doctor orders 1,000 milliliters of half normal saline. This is a type of fluid. This is example of a type of fluid. Sugar water, normal saline, but this one just happens to name the type of fluid. Nice information to know if you're practicing. You don't need it to solve this problem though. But the doctor wants 1,000 milliliters of half normal saline to run over 10 hours via a pump. Computer, what is the infusion rate? Or it could say, what is the flow rate? Or it could say, what is the drip rate? The key word for the wanted is it's asking you for a rate. That means how fast you're going to run something into a patient or infuse. If you see the word rate, I want you to do this just until you don't forget. If I'm solving for rate, I have to see, number one, do I have an IV pump? And in this question, do I have an IV pump?
Yes.
Yes. So what is my wanted? What am I solving for rate?
MLs per hour.
Milliliters over hour. Milliliters in the numerator, hour in the denominator. Okay. What's the doctor's order? Milliliters. 1,000 milliliters volume over time. What time do I put down here?
10 hours.
10 hours is not a trick question. So do I have my wanted?
Yes.
I do. So what's 1,000 divided by 10? What's my answer?
100 mLs per minute.
There it is. That means I'm going to puncture my bag, poke the tubing through here. I'm going to punch into this computer 100 and hit start. And it will deliver 100 milliliters of half normal saline every hour for 10 hours. And in 10 hours, the patient would have received 1,000 milliliters. That's it. Where you guys get hung up is if in the question it says that the tubing has a drop factor of 20. Infuse 1,000 milliliters of D5W and half normal saline over 8 hours via an IV pump. What's my answer? I have a pump. What am I solving for? Milliliters per hour. 1,000 milliliters over 8 hours. What's the answer?
125.
125 milliliters an hour, and that's how you have to write it. So please do this one. I'll give you a minute. Yes. Remember, you got to include the full unit of measure. So this has a lot of information in it. But what is it asking me for? Infusion rate. So if it says rate, I have to decide if I have a pump or if it's going to be gravity. So if the word pump is in the problem and it's asking me infusion rate, it's milliliters an hour. What do I do with the drop factor though? Nothing. I cross it off. It's just information. Just like this, it's important information if something goes wrong, but it's just information. I don't need it to solve my problem. People get these wrong because they try to fit it in there, okay? So I'm looking for volume over time. 1 liter over 6 hours. Now, 1 liter, if you don't know that 1 liter is 1,000 milliliters, you would have to solve to figure it out. So 1 liter is 1,000 milliliters, right? That's one of the conversions you remember. But if you couldn't remember, you would have to do 1 liter. It would tell you when you solve for it like this, because you would automatically remember. So I'm just going to go and start with 1,000 milliliters over 6 hours. That gives me milliliters in the numerator, hour in the denominator. And when I do my math, I'm going to put 1,000 divided by 6, and that will give me 166.66. When I have a computer, I'm going to follow the rounding rules. So anything greater than 10, I round to the whole number. I look to the right, it's 5 and up, so this number will become 7. So I will put into the computer the IV pump 167 milliliters per hour. Don't forget the full unit of measure. You will get points taken off. No, actually, you get it all wrong. If the unit of measure is wrong, you lose all 5 points. All right. So what about this one? You got it. Very good. Good. Yep. Good. All right. So I think you understand it. So it says rate. I have a pump. It's milliliters an hour. So I need milliliters in the numerator, hour in the denominator, and that's in my question. I know 1 liter is 1,000 milliliters. So 2 liters is what? 2,000 milliliters. And I have to give that over 8 hours. So this gives me my units of measure. So it's just math. 8 divided into 2,000 will give me 250, milliliters an hour. And I would plug that into my computer. All right, cool. So here again, another example, because it's saying flow rate, infusion rate, drop rate, and I have a pump, I don't need the drop factor, okay? Now this one I want you to look at real quick. This has more information in it. Potassium is a vitamin supplement we give patients. And you're going to learn all about potassium in 118 if you're taking it. So this is saying there's a bag of 1,000 milliliters of D5W. And it's 1,000 milliliters. And inside of it, there's 40 milliequivalents of potassium. But it's asking me the rate. What is the flow rate, the infusion rate? The rules don't change. If it's asking me the rate, I have to decide, is there a pump or not? Because rate means how fast am I going to run it over how much time? Just because there's medicine in it, it doesn't matter. It doesn't matter. Not for this equation. I'm not asking you to solve for the strength of a medicine. So I have a pump. It says a pump. So if I'm infusing it, oh wait, actually this one does not say pump. I'm so sorry. This one does not say pump, right? Do you see that? But what is it missing? Why can't I solve for gravity?
The drop factor.
It doesn't have a drop factor. So if there's no drop factor, I have to assume that it's an IV pump. So it's going to be milliliters an hour. So let me see. There was something else. Oh, okay. Now let me go back to my regular stuff. So we did those. So here, I want you to solve for this one. And I'm going to pause the recording. Very good. All right. So let's do this one. What is the infusion rate? There's the word for an IV ordered 1 liter per day via pump. So it's asking me rate, and I have a pump. So that means I don't need to use a drop factor if it's there, but it's not. So I'm solving milliliters an hour. So 1 liter, let's use 1 liter is my given. But I need milliliters. So I know that 1 liter is 1,000 milliliters. So I cross off my liters. So I have milliliters. Now, how do I get, sorry, it's 1 liter per day. Sorry. So when I say per day and I need hours, what goes down here?
Day.
Well, how many hours are in a day?
24 hours.
So that's what I would put, 24 hours, because I need hours. So yes, so it's 1 liter per day is 24 hours. So now I'm going to multiply 1,000 times 1 and 24, and then I divide 24 into 1,000, and my calculator will give me 41.6666666. Any number greater than 10, I round to the whole number. I look to the right. It is 5 and up, so I'm rounding this 1 to a 2, and that is 42 milliliters an hour. Beautiful. All right. I'm going to give you a minute to solve this one. I know you can do it. All right. You guys got it. So I've got the word rate. I've got a pump, milliliters an hour. Beautiful. That means I do not need the drop factor. So I look for volume over time. I need
Professor K, I
milliliters.
have a question.
Sure.
Because this is why I got confused, why I originally thought it was 217 versus the 200 ml per hour. Where would be the problems where we would have to multiply the minutes by 60?
We're moving into that. That's the next one.
Okay. Okay.
Yep, no problem. So we have milliliters in the numerator, hour in the denominator, and now it's just math, and it will be 200 milliliters an hour. Beautiful. All right, now here is where we move into the drops per minute. So what is the drip rate? There's the word rate, but I don't have a pump, but I do have a drop factor. So what am I solving for? What's my wanted? Drops per minute. That's my wanted. All right. So what's ordered? 1 liter. 1 liter is how many milliliters? 1,000 milliliters. And per day is 24 hours. Do we agree? Yes. Good.
Yes.
All right. So how do we get there now? So how do I like to start on the denominator. How do I change hours to minute?
1 hour per 60 minutes.
There it is. 1 hour is 60 minutes. That gets rid of hour, and there's minutes. So now I have to get rid of milliliter and get to drops. I've used everything in my problem except for the drop factor. So what does it mean the drop factor is 10? What does that mean?
And drops per minute.
It takes 10 drops to make 1 milliliter. So that's what I'm going to use. 10 drops to make 1 milliliter. And that crosses off my milliliter and leaves drops. That's all it takes. So now we just multiply across the top and the bottom. You can cross off the zeros if you want to, but let's just keep it 1,000 times 10 is 10,000. And 60 times 24 is 1440. And when I do the math, it'll give me 6.94. So here's the thing with drops. Can I split a drop? Not unless I'm a ninja, because it's what literally drips in a chamber. I have no control of it. There's no computer. It's just gravity. So when we are talking about drops per minute, it's always a whole number. So what's the final answer?
7.
7 drops per minute.
7 drops per minute. There it is. Boom. All right. So here it's asking me for rate. So if it says rate, do I have the word pump? No. Do I have a drop factor?
Yeah, the micro drip.
There it
Yes, the
is. I
micro drip.
knew. So I'm solving for drops per minute. Beautiful. So they want me to give 1,500 milliliters over an 8-hour period, volume over time. So now it's a process of elimination, right? So I've used this. I know how long. So how do I change hour to minute? The same way, right? 1 hour is 60 minutes. Now I have minutes in my denominator. How do I get rid of milliliter? I've used everything except what? The drop factor. So here you need to know that micro drip means what?
60 drops.
There it is, 60 drops to make a milliliter. So to get rid of the milliliter, I'm going to put 60 drops over 1 ml. And just like that, got rid of milliliter. Now I have drops per minute, and now it's just math. So the math on this one, you can cross off like amounts. Remember I said that? So you can cross off the 60 on the top and the 60 on the bottom. That's totally fine. And when you do that, it's literally 1,500 divided by 8, and that will give you 187.5. And remember, no matter what the number is, I cannot split a drop. So what's the final answer?
188.
188 drops per minute. Beautiful. Okay. I want you to solve this one. I'm going to pause. I'm going to give you a minute. All right. I'm liking what I'm seeing. Very good. All right. A lot of information in here, but I'm going to keep my focus. This one tells me what to solve for. So it's telling me to solve drops per minute. So I'm solving for a rate. So it's saying how many drops per minute. So I know that I got to look for volume and time because it's telling me that I'm solving for a rate. So 50 milliliters is my volume over 30 minutes. So a lot of people get confused because they're like, oh, it's gravity. I got to do 1 hour. It's 60 minutes without even looking at what they have in front of them. You already have the minutes. So one of the biggest errors I see is people try to add 1 hour, 60 minutes into this problem and they get it wrong without even realizing, oh gosh, it's already in minutes. So that's why I always encourage putting the wanted right there in front of you, because if you see it, hopefully it will trigger something and say, oh wait, I got minutes. So if I have minutes, I just need to work on getting rid of the milliliters. So 50 milliliters over 30 minutes. I have a strength, but I'm solving for a rate. I didn't ask you to solve for the strength of a medicine. All right. So I need to get rid of only the milliliters. So I can do that with my drop factor. So it's 10 drops for every 1 milliliter. And by doing that, I'm ending up with drops per minute. So now it's just math. So it's 500 over 30, excuse me, and then that will give me 16.66. Any number, well, it's a drops per minute, so I can't split a drop in a chamber. So the answer is 17 drops per minute. Very good. I think you got it. All right. So the other examples, now these are all taken from all the sheets that you have. This is another IV type of question, but this one's asking you something very specifically. So I'll do this one with you. An IV pump, so right away I know I have a computer running because it's telling me it's set to deliver 13 milliliters an hour. The actual bag that's hanging, the IV fluids that's hanging there, has a label on it, and it's telling you a concentration of the drug that's in this. So the drug is 1 gram and the whole bag is 250 milliliters. So it's a small little bag. It has a drop factor of 20, but it's asking me how many milligrams an hour. That's my wanted. So milligrams an hour is what I have to solve for. So I need milligrams in the numerator and time, hour, in the denominator. So just by looking at this, if you were looking at this on your exam, I have a pump. Do I need the drop factor?
No.
No, I do not. So I'm going to get that out of my eyesight because I can't. I'm too tempted. All right. I'm the one that sees a squirrel and I've lost it. I'm gone. Okay. So I'm going to eliminate the 20. I don't need the drop factor. Get it out of there. So I have to solve for milligrams an hour. So what in my problem has anything related to my wanted? I have to solve for milligrams an hour, and I have something right here that I can start with that has part of my problem. 13 milliliters an hour. That's what is set to be delivered. The doctor ordered that, but it also has the time that I need. So I'm going to start with what, if it's there, I'm going to start with what I need. So I already have hour. So now I just got to get rid of milliliter and get to milligrams. No problem. I've used everything in my problem except the concentration of the med. So let me use it. 1 gram in 250 milliliters. So now I've used the concentration. I cross off milliliters. But am I done? I've used everything in my problem, but am I done?
No, you have to convert grams to milliliters.
Right on. So even if you're like, you look at this type of question, you're like, oh my God, I think I just lost a brain cell through my ear. If you just take a minute and sit back and look, wait a minute. I know that conversion, gram to milligram. Okay. Nope, don't panic. 1 gram is 1,000 milligrams. And then all of a sudden, oh, 3 fractions? I'm a pro. This is nothing now. And now I'm ready to solve. That was it. So this big problem that has all this information, which is how things are ordered, you can simplify into 3 fractions and get an actual answer. So when would I ever use this? So you're working in, let's say, cardiac CCU, and your patient has a amiodarone or a cardiac drip going at 13 milliliters an hour. Oh, it sounds so serious. Yeah. And then all of a sudden the patient's heart rhythm gets a little funky. And you call the doctor, he goes, well, how many milligrams is he getting every hour? This is a real type of question. Nowadays, I know the computers that you just press a button and it tells you, but computer systems go down. We have to be able to know how to solve for these equations. So it's pretty awesome that this is interchangeable. And if you kind of look at calculations as like a gamification of getting rid of things and trying to solve, you could actually have fun with it. I know right now it's going to be torture, but you could have fun with this. So now it's just math. So when we do the math for this equation, it will be 13,000 on top and 250 on the bottom. When I divide, it will give me a solid 52 milligrams an hour. So you see these big questions and it's a little bit intimidating. But again, if you just look at it and remember, okay, I know what my wanted is, and I have a pump, so I don't need the drop factor. You can do this. All right. So when you look at this question, you already know milligram an hour, and I got something going at 20 milliliters an hour. I've got half of my problem done. I've got a pump. I've used this. I know what I solved. I've used this. The only thing I haven't used is my concentration. So I'm going to use it. 2 grams in 150 milliliters. No problem. Oh, grams to milligram. No problem. What if it was milligrams to micrograms? What if they wanted you to solve for micrograms per milligram? No problem. So once you know the conversions, you will be able to plug them in. And it's that muscle memory that you'll start to gain as you practice. And I know you guys are going for it, man. And I love that you are taking the challenge. I love this. All right. So it's totally doable. It is. And I would never tell you that if it wasn't. All right. So when you do things like this, I think you can manage this stuff. Now, where it gets really crazy, and we're definitely going to run over, and if you have to leave, that's fine. As soon as Zoom gives me the recording, I will post it again, provided there's no problems. But I'll just keep talking all day and night. If you're going to listen, I'm here. All right. So now we move into 3-factor. And everything I'm showing you today, you can safely anticipate you will see and should be prepared for, okay? So what is a 3-factor? It just means there's 3 parts to the doctor's order: the strength, the patient's weight, and time. Strength, weight, and time, 3-factor. How do I write a 3-factor? Just like that. All right. So the recommended dose for a medication is 8 milligrams for every 1 kilogram for an entire day. And you'll see this a lot for children as well. But this question says, what would the daily dose be for an adult weighing 105 pounds? All right. Daily dose. What do you think my wanted is? Just think about it.
Milligram per dose.
Milligrams per dose?
Milligrams per day.
Milligrams per day? All right. So this is where most people get confused because it says the word dose. So you're thinking, is it per dose? But this question says per day and doesn't indicate, am I giving it several times a day?
Dose a day?
So it is milligrams a day. All right. Milligrams is the dose is the strength in milligrams per day. So look at this. I have milligrams and per day. So what do I have to do to solve?
Convert the pounds to kilos.
That's right. I got to get rid of this crusty little kilogram right there that's blocking my success. I got to get rid of kilogram. So the patient's weight is in pounds. So what do? 1 kilogram is 2.2 pounds. Crosses off my kilograms. So now I got to get rid of pounds. And then I'm going to insert patient weight, 105 pounds. And I'm going to put it over 1 because you already know I can't have a blank space because I'll put things in it. So I cross off pounds. So now all that is left is exactly what I need. Milligrams per day. Milligrams per day. I know it looks weird, but that's the only thing we have that's actually a dose is the milligrams. So now it's just math. So when we do the math across the top, it is 105. And when I do it across the bottom, it's 2.2. And then when I divide on my calculator, it'll say 47.73. Any number greater than 10, I round to the whole number. I look to the right. It is 5 and up, so I round the 7 up to an 8. So the recommended dose is 48 milligrams per day.
Professor, how about the
Yes.
8
You have to multiply
milligram?
by 8.
Wait. So what? Oh, I'm sorry. Yeah, the 8 times 105. I'm so sorry. Thank you for catching my math. 8 times, wait. Give me a minute. I just erased my work. I'm sorry. 105 over 1. 8 times 105 is what? Sorry. I got to do the math. 8 times 105 is. Did you guys get 840?
Yes.
Sorry. Thank you. Oh my God. No. Hold on, stand by. Stand by. 840 over 2.2. See, I told you if I see a squirrel, that's it. So the answer will be, what is it? I got
382.
1.818. So the answer is 382 milligrams per day. You with me? All right. Do this one for me. I'm trying to catch up on all the answers. All right. So this one is grams per day. That's what you're solving for. So if you put milligrams per day, it's you're solving for grams because that's the dose. That's what the wanted is. That's what's the doctor's order is 1.5 grams per kilogram per day. So the daily dose has got to be in grams per day because that's what we're working with. This one was milligrams. So it's basically whatever unit of measure is being used when it's asking for daily dose. All right. And Jen, you asked a good question, and I'll show you the difference because we're going to do that next. So per day, what is the daily dose for a child weighing 60 pounds? So we're still going to do the 1 kilogram is 2.2 pounds to get rid of kilograms. And this kid weighs 60 pounds over 1. So I'm going to do the math. So make sure I'm not making any errors. 1.5 times 60 is 9. And then 2.2. Hold on one second. No, okay, so 90 divided by 2.2 will give me 40.90, and any number greater than 10, we round to the whole number. So the answer will be 41 grams per day. Okay, so now you asked Jen a great question about when do we use per dose? Because it'll say per dose and it'll give a time. So I'm going to show you what that looks like. Here's the difference. So when you look at this question, it says a medication is prescribed and it's 3-factor, 500 micrograms per kilogram per day. So I'm going to write 500 micrograms per kilogram per day in 3 divided doses. This could also be written as TID. It may say 3 equally divided doses or whatever it may say, or like you said, TID. So it's being given 3 times a day. The patient's weight is 90 kilograms. What the pharmacy delivers to you is 500 milligrams per 2 mLs. But now this question is asking you, what is the dose you're going to give at 8 a.m.? What are you going to give the patient? So people get hung up on the word. Well, dose in the last question meant the strength. But this time, what am I going to physically give the patient? I already know the strength. The doctor ordered 500 micrograms per kilogram per day. So what am I going to give the patient? What do you think I'm solving for?
Milliliter.
Milliliter what? Over what?
Yes, per kilogram. Per dose.
So it's asking me to calculate the dose that I'm going to give at 8 a.m. So 8 a.m. is one of those TIDs. So TID means maybe he's getting a dose at 8 a.m. and then a dose at 1300 and then a dose at 2200. That's 1, 2, 3 times a day, right? But we want to know how much we're going to give for the 8 a.m. dose. So what am I going to give at the 8 a.m. dose? Bianca, you had a question? Wait.
Yeah, I'm so sorry. I had a question regarding the previous question that we were doing, the 41 grams per day.
Okay.
If on the exam I were to put something like 41 grams per dose, would that be incorrect? It would have to reflect day or
Yes, because if you put 41 grams per dose, you would overdose the patient because per day means for 24 hours.
Got it. Okay.
And if you wrote dose, that means if the patient ended up getting it 4 times, you would have overdosed the patient. That question, these questions are saying, what's the safe amount the patient should get for the entire day?
Mm-hmm.
Honestly, if you don't know what to put here,
mm-hmm.
and you just gave me 41 grams or 382 milligrams, I would know that I'm asking for the day. So if
Okay.
you're not sure, just don't put it.
Okay.
But for when you're solving for the dose, I need to know that you know that 8 a.m. dose at 8 a.m. at that time, that dose,
Mhm.
it's a dose per one dose.
Got it.
All
Okay.
right.
Thank you.
Sure. So now I need to calculate the dose I will give at 8 a.m. And I'm physically going to bring them a liquid, so it's milliliters. That's how it's given to me. That's what's available to me. All right. So I always start in the denominator. So how do I change day to dose? Well, to change day, I have to write the word day here, right? That's the only way I can cross off. So every day, how many doses is the patient getting? Three
Three.
doses. There it is. So I just got rid of the word day. And I have dose. I have to get rid of kilogram. So I'm going to use 90 kilograms. That's the weight. Got rid of kilogram. Beautiful. So I've used the given. I know my doses. I have the weight and I know what time. So the only thing left is the concentration that's available to me. And I'm solving for milliliters, and this is in micrograms, and this is in milligrams. This is where you have to pay attention. I'm just going to move this over a little bit. So, okay, so I have room. So if this is milligrams, how do I get rid of my micrograms? I need my conversion, right? So 1 milligram is 1,000 micrograms. And to get rid of the milligrams, I'm going to use my concentration. And that leaves me exactly what I need. So it's when you have to do these conversions that people get confused. That's why I like to use the given, the wanted. If I know where I'm starting and where I'm ending, and I just cross off as I go along, you can get to the right answer in the setup properly. So now when you do the math on this enormous question, does anybody have the answer? Well, let's do it together then. 500 times 90 times 2 is, what is that, 90,000? That can't be right. 500 times 90 times 2 is, oh, it is right. I'm going to put it down here so I can see it. 90,000. And then 3 times 1,000 times 500 is 1,500,000. So now I divide. You got it, Julius. 0.06 milliliters per dose. So that means I'm going to draw up, provided the 0.006 milliliters at 8 a.m., 0.06 milliliters at 1 p.m., and 0.06 milliliters at, what is 2200? Okay, good. Yes. So that's what that means per dose. I'm going to divide give my doses in this manner. So I'm going to let you solve for this one. And I'll give you a few minutes. I'll give you a minute and a half. How about that? Very good.
Yeah, Professor, I'm still going to have to talk about what my actual question was because that
Sure.
didn't.
Go ahead. You can talk about it.
No, but they're working on a problem.
Okay.
I did, because I was going over one of the worksheets I believe I saw there, or one of the videos.
Okay.
And I was just confused as to, it said to like cut the volume in half. Is that correct?
Yes. All right. So let's say you bring your patient, let's say where you work. Well, no, we're going to use RCC. So RCC, we give 1 cup, and we know that 1 cup is 240 milliliters. So if we filled a cup with water, it would be 240 milliliters. Do we agree, right? But if we take the same cup and we fill it with ice cubes, all right, when the ice melts, it's half the volume. So instead of if I used a cup that the whole cup is 240 milliliters, but I only filled it with ice, when the ice melts, you would calculate that as 120 milliliters. Does that make sense? Are you questioning everything you ever thought about nursing now?
Yeah, so when we're doing like intake,
Mhm.
and output,
Uh-huh.
since it's, so we would just calculate it as 120 ml.
Correct. So if the question said the patient had 1 cup of ice, we know that 1 cup is 240 milliliters, but you also must know that if it's ice, when it melts, it's half the volume. And it's actually, if clinically, when you're working, there are patients who are on fluid restrictions and they're not allowed to have a lot of fluids. And giving ice chips is a great way to make them feel as if they're getting a lot when they're only getting half the volume. So, yes, the rule for ice chips is half when they melt. Cool. All right. Before it's midnight, let's do another type of question. All right. So, here's another doozy. We're definitely into our critical care meds at this point. So I want you to look at this question. An IV medication is to be administered at 22 micrograms per kilogram per minute, a 3-factor. 22 micrograms per kilogram per minute. Wow. So I know that that's my given because the doctor said administer it that. The IV is labeled 500 milligrams and 500 milliliters. I have a patient weight. I have a drop factor. And then I have what it wants. Calculate the infusion rate for this IV pump. So please tell me what my wanted is.
MLs per hour because it says pump.
Milliliters an hour because it's saying rate and I got a pump. That's what it is. So I know what I'm solving for. Awesome. Now we eliminate what we don't need. So I like to start in the denominator. So I'm going to change minutes to hour. I need hour. So how do I change minutes to hour?
One hour and 60 minutes.
Thank you. 1 hour is 60 minutes. Yay. So I cross off my minutes and I have my hour. Now I have to get rid of kilogram and my patient's weight is in pounds. So 1 kilogram is 2.2 pounds. Gets rid of my kilogram. Now I have to get rid of the pounds. The patient weighs 120 pounds. I put that over 1. I don't need any spaces. I get crazy. Cool. So now I'm looking and I have hour in the denominator, but I need milliliter in the numerator and I have a microgram. So I've used that. I've used the weight. I don't need the drop factor because I have a pump. The only thing left is my concentration, but it's in milligrams because Professor K is a monster. So I have to do a conversion, right? So 1 milligram is 1,000 micrograms. Crosses off my micrograms. And now how do I get rid of the milligram and get to milliliters? Going to use that concentration. Boop, 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 boop. So it's going to be 500 milligrams in 500 milliliters. Cross off my milligrams, and guess what? It's true. I'm done. That's a good one. I like it. So I can cross off like amounts, the 500s, to make my problem a little more manageable. And now it's just math. All right, so 22 times 60 times 120 is 158,400. And then I have 2.2 times 1,000, 2,200. And then when I do my division, 158,400 divided by 2,200, I get a rock and roll number, and that is I am going to set that IV pump at 72 milliliters an hour, and this patient's probably going to get this very serious cardiac med infusing into them. Yes, Julius.
Professor, can you
Yes.
go back to the previous question?
I refuse.
I would like to
Yes.
know what was the answer you got?
The previous.
Yes, this
I
one.
sent you a
No,
question regarding that question too.
Which one?
yeah, this one. The medication, yeah, 4.6
The
milligram, and
4
I want
milliliter
to
answer.
see the setup for the day, the dose, please.
All right. You ready? The doctor orders 4.6 milligrams per kilogram per day. The patient's going to get it every 6 hours. The patient weighs 7 kilograms. This is the available concentration. You should notice that one is milligrams and one is grams. And they want to know what you're going to give at the specific time, 7 a.m. What dose at 7 a.m.? A specific dose. So how often is every 6 hours? How often is a patient receiving this med?
Every 4 hours.
4 times a day.
Every 6 hours is 4 times a day. Oops, times a day, right? So let's look at it. So what am I solving for? It comes in a liquid, so it's milliliters per dose. It's asking me a specific time to solve for. So this patient's going to get it 4 times a day, so it may be 700, maybe 1200, and maybe I don't know, give me something. I don't know, maybe 0400, but either way, they're going to get 4 doses, 4 times, right? So I have to keep that in mind. So I'm solving for 1 dose, the 7 a.m. dose. All right. So I need to get dose in my denominator. How do I get rid of the word day? I write the word day, and every day he's getting what? 4 doses. Beautiful. So now I have dose. I got to get rid of kilogram. The baby weighs 7 kilograms. Beautiful. Now I got to get milligrams. I've already used this. I've already used this. I already know what I'm solving for. So I have milligrams and I need milliliters. So I have a concentration, but it's in grams. So I need a conversion. 1 gram is 1,000 milligrams. That gets rid of my milligrams. And now I can use the concentration. Zero, and this is where you have to be very careful when you're transcribing. I see errors all the time. 0.008 grams in 4 milliliters. Cross off my grams, and now I have milliliters. So I have milliliters per dose. And how do I know? Jen will tell you. Because the problem has a specific time. It's asking for a specific time you need to solve. So now it's just math. So the math across the top, 128.8, and then 32. Hopefully. And then when you divide, it'll give you 4.025. So I'm rounding 1 to 10. I round to the tenths. Sorry, the tenths. So I look to the right. So 2 is not 5 and up. So I do not round this up. But I can't write 4.0 because that could be mistaken for 40. So it is 4 milliliters per dose with a smiley face. What do you think, Julius? Pretty good?
Yes,
Teacher of the year? No.
my calculator made a mistake and gave me 1288. That's why I got a wrong answer.
Ah, that's it. Get a new one. That's it. No problem. All right. So do you want, I'll have you solve this one. I'll give you a minute. All right. What my critical care nurses are at. All right. I'm loving these answers. Great job, you guys. All right. Let's break this down. All right. It's another 3-factor, and the doctor wants us to administer this IV med at 100 micrograms per kilogram per minute. Beautiful. I got you. All right. So what am I solving for? What is my wanted? Well, there's that word rate, and I got a pump. So it's milliliters an hour all day long. I'm not going to get distracted. I don't need drop factors or anything like that. So I know I'm solving for milliliters an hour. Beautiful. So let's start eliminating and changing things. Let's get it done. I'm going to change minute to hour. So 1 hour is 60 minutes. No problem. I cross off my minutes and now I have hour. All right, now how do I get rid of the kilogram? I'm going to use the patient's weight, but Professor K is a monster. She put it in pounds. All right, 1 kilogram is 2.2 pounds. And then I get rid of the pounds by 225 pounds over 1. No blank spaces, no problem. So I've used the weight. So everything in my denominator is gone except for hour. Lovely, I love it. All right, so now I got to get milliliters in my numerator. So I have micrograms. I've used everything except my concentration. That's the only thing left, but you see it's in milligrams and I have micrograms in my problem, so I need a conversion. So 1 milligram is 1,000 micrograms. Crosses off my micrograms. So now how do I get rid of the milligrams? Use my concentration. When I do that, it'll also give me my milliliters. So 300 milligrams in 150 milliliters. Crossing off my milligrams, that leaves me with milliliters in my numerator. So I am ready to solve because every other unit of measure is removed. So now it's just math. It's gross math. It's quite disgusting, but it's math nonetheless. Let's cross off some zeros. I don't know. Let's get it going on here. Let's do 1, 2, 3. 1, 2, 3. Do I got any others? I can do another one. A 0 here and a 0 there. You just got to be careful when you cross off your zeros. So now I'm going to do 1 times 6 times 225 times 15. That should give me, hopefully it's right, 2250. But I'm sure one of you will let me know. And I don't mind that, trust me. Then I got 2.2 times 1 times 1 times 30. And that will give me 66. So when I divide, I should get on my calculator 306.8181. Any number greater than 10, I round to the whole number. I look to the right, it is 5 and up, so that 6 becomes a 7. So it'll be 307 milliliters an hour. That is beautiful. Gross when you count the fractions, but beautiful kind of math. All right, good job getting that. Before I move into the final thing, I just have some silly stragglers that I want to just ask you about. These type of questions is just to really challenge your ability to be careful and accurate and use your rounding skills. So could you guys tell me what the answer to this question is right here? Not a trick, just an honest question. I just want to know what you would put as your answer.
$1.4 milligrams.
I heard 1.4 milligrams. Everybody agree? So this type of question is just simply asking, the patient had 4 injections, 4, and each injection was 0.345 milligrams. What was the total amount of medication the patient received for the day? So it is as simple as going 0.345 milligrams times 4. When you do that, what do you get?
1.38.
You will get 1.38. So what is the final answer you will write on the answer line?
0.38 milligrams.
No, this would be -1, rounding. So remember, any number between 1 and 10, you round to the 10th spot.
Even though we're reporting how much they actually had, not everything else we did was what are we giving them?
But we always follow the rounding rules, and that's why I wanted to review it. So no matter what, we follow the rounding rules for RCC, okay? So in this case, the answer would be 1.4 milligrams. I don't want to butcher your name.
Yeah, that's okay.
How do you say it? Tell me.
It's Akosua.
Yeah.
Yeah, you
I
got
love
it.
it. I could see.
You know, Professor, I was doing that same question on the prep questions that you gave the week 4, and I think that's the number 10. I had my answer to be 10.75. Then per the rounding rule, per the rounding rules, I just decided to put in 11.
Yeah.
But your answer for that question was 10.8.
No, I'm wrong. Definitely
Okay,
send me
thank
that one.
Oh,
10.75, greater than 10 or up. You rounded the whole number, so the answer is 11. Definitely send me that one. Actually, let's do this one. Do this one and tell me what the answer is.
And milligrams.
Yeah, 10 milligrams.
I don't like that at all. I don't like. I
don't
feel
like
like if
anything
we're
right now.
I feel like if we're reporting what somebody had, I just feel like reporting should be what they had.
Disagree.
I mean, I can I can follow rules. I'm just saying I don't like it.
Yeah, trust me, some things I don't like either, all right? But yeah, we got to follow the rounding rule. So I just like to go over it because obviously I go over it because I kind of feel the same way. So I'm going to just review it so you don't lose any points if you were to come across this question. Just follow the rounding rules.
Thanks.
All right, now the final thing I do want to review with you is either you love or hate these questions. And really, it just takes practice. And I know we ran over, so thank you for hanging out with me. But it's about time and IV fluids. So the reason we solve for these is to get you comfortable with knowing when you have to return to a patient's room to bring a new IV bag in, let's say. So in this question, it's just giving you a lot of information because it's information you more than likely will receive when you're getting a report from your colleague when you're working. All right. So there's an IV that's running, and when they hung the IV, when they hung it, there was 500 milliliters in this IV bag. And it was running at 10 drops a minute. So let's say you're working at Pine Valley and you're doing drop factor. So your colleague hangs this bag and you come in for your 3 to 11 shift. So they tell you, yeah, I hung a 500 milliliter bag of whatever, D5W, it's going at 10 drops a minute. I have to provide the information to you that there's a drop factor so you know what that is. But usually in report, they're not like it's 15 drops per milliliter. You'll know when you work there. So there's an IV that was started and it's going at 10 drops a minute. The drop factor on the tubing is 15 drops per milliliter. But you go in the room at 1400. I walk in the room at 1400. And there's 300 milliliters, LIB means left in the bag. What time will the IV finish? So a lot of people get confused. Well, which one do I start with? Well, number one, I'm solving for time. So when we solve for time, we're solving for hour over 1. Okay? But people are like, which one do I start with? Does anybody know which one we start with? Do I start with 500 milliliters in my problem or 300 milliliters?
300.
Why?
300.
It's left. And we know the time.
Because
That's
I
what
wasn't.
is
Go ahead.
bad.
I'm sorry. Go ahead and say it. You're right.
I said that's what is left in the bag at the
Yeah.
time that we got the.
I don't care what Sarah did 2 hours ago. I walk in the room and I see 300 milliliters in the bag. When am I coming back in the room to hang a new bag so it doesn't go dry and empty and get air in the patient's veins? So I am concerned about what I saw and at what time. So I'm going to always start these questions with what's left in the bag. All right. Beautiful. Now we know that. So now I have to figure out how to get rid of milliliters and get to only hours. And there's a lot of stuff in here. So I already know I don't care about the 500 milliliter bag. I've already used the 300 milliliter bag and I know I'm solving for hours. So you see what's left in my problem, right? If you do it this way, it might help you. Do whatever works for you, but it might help you. So which would I put out of these two? Which do I put next to get rid of milliliters?
15
15 drops per ml.
milliliter.
Yeah, 15 drops per milliliter. Beautiful. I got rid of milliliters. Yay. Now, how do I get rid of the drops?
10 drops per minute.
Yeah. So I'm going to put 10 drops per minute. Okay. How do I change minute to hour?
1/60.
1 hour, 60 minutes. Yes. Yay. That's the easy part, right? So I did all this fancy jazzy stuff because I'm just feeling so good about myself. And now I have to solve for this hour. What is it going to give me when I solve for this? So when I do 300 times 15, it'll give me 4,500. And 60 times 10 is 600. And when I do the math, it'll give me 7.5. And this is where people start losing their mind because we don't deal with time that's 0.5 or anything like that. So I'm going to say this. Anything before the decimal, in this case 7, represents 7 hours. Anything after the decimal will represent minutes, but I don't know anything that is time in 0.5. So 0.5, anything after a decimal doesn't represent true time. We have to make it true time. And I know some people, we defy the logic of math. We call it nurse math because it seems like we just do what we want. But there is a logical reason behind it. So how do we get that 0.5 to represent real minutes? We multiply 0.5 times 60. When we multiply 0.5 times 60, what number do we get? So you would literally put 0.5 times 60 in your calculator, and it gives you what? 30. So 0.5 represents 30 minutes. Okay, 7 hours and 30 minutes. What time am I going in that room with a brand new bag?
(9:30 p.m.)
We always answer in military time.
21:30.
100 hours.
Ah, now you're talking. I walked in that room at 1400. It's going to take 07:30 because I'm talking about time. All right. It's going to take 7 hours and 30 minutes. So I'm going to go back in that room because the IV will finish at 21:30. So how do you write military time? 21:30. No decimals, no colons, no AM, no PM. That's why we use military time for passing meds. Because if it's 21:30, there's no confusion. If somebody just wrote, let's say, wrote that, is that AM? Is that PM? So we always solve for military time. Have I blown your mind? Yeah. So people hate these. I actually like these kind of questions, but there I am, the nerd that likes it. All right. So remember, I always said don't round to the end. So I want to do this one with you as well. An IV of 1,000 milliliters of D5W sugar water is infusing at 73 drops a minute. At 8 a.m., I walk into the room. Hi. And there's only 550 milliliters left in the bag. What time will this IV finish? Drop factor 25. So where do I start? What's my given? What am I starting with in this problem?
550 ml.
550 milliliters. Wow, that is what's left in the bag. So I don't care. It's not that I don't care. I just don't need the 1,000 milliliters. All right. And I'm solving for time. So what am I putting in my numerator in the wanted?
Hour.
Hour. Got to put it over 1. I get distracted. All right. So now I got 550 left in the bag. I start with left in the bag. Beautiful. Now let's start eliminating. How do I get rid of milliliters?
The
Drop
drop.
Drop factor, yay! 25 drops per milliliter. You did it, you did it, you did it. All right, and then how do I get rid of drops? I'm going to use 73 drops per minute. And then how do I get rid of the minutes to hours? 1 hour is 60 minutes. I love it. I love it.
How do
All
you
right.
roll?
You with me still? Okay. I know, I'm defying all rules. I'm a rule breaker. So now let's do the math. So when I do the math across the top, it'll give me 13,750. And when I do the math across the bottom, it'll give me 4,380. So when I solve for that, I will get 3.139 The 3 is what? 3 hours. You see all these numbers, 1, 2, 3, 4, 5, 6 digits long. Keep as many as you can keep because it matters. Never round until the very end of your problem. So 0.139269 times 60 will give me 8.35. So how many minutes would you say that is?
8.
8. Very good. So that is 8 minutes. I love it. So 3 hours and 8 minutes. Be careful when you write this. So we walked in at 8 a.m. It's going to take 3 hours and 8 minutes to complete. So what is my time that the IV will finish?
Um,
11:08.
11:08.
11:08. Now, the reason I say make sure you keep all these digits, if you shorten it to make it easier math, you're going to get the answer wrong, guaranteed. Maybe not every time, but the majority of the time, if you shorten it, you are going to lose a few minutes and the answer's wrong. So please make sure you use as many numbers as you can fit on your calculator. All right, I'm going to let you do this one all by yourselves. I feel like I've raised you well. All right, so go ahead. I'm getting a little squirrely, so I'm going to pause and let you try to solve this one. You can do this. Yeah. All right, so let's go through it again. An IV of 1,000 milliliters of 0.9 normal saline is infusing at 50 drops per minute. And the drop factor is 20, which means 20 drops per milliliter. And at 8 a.m., I walk in the room and there's only 500 milliliters left in the bag. What time will it finish? Time, I'm solving for hours over 1. So what do I care about? Everything in this world, but in this question, only the 500 milliliters, the starting point. 500 milliliters are left in the bag, and that was at 8 a.m. Beautiful. All right, so let's start eliminating. How do I get rid of milliliters? I use the drop factor, so it's 20 drops per 1 ml. Beautiful. And then how do I get rid of the drops? I use what it's infusing at, 50 drops per minute. And then I change minute to hours by saying 1 hour is 60 minutes. And now everything's been eliminated and it's just math. So when I do the math across the top, 500 times 20 times 1, 10,000, and then 50 times 60 is 3,000. When I divide, my calculator will give me 3.333333. At least 6 digits is safe, I say. So the 3 before the decimal is 3 hours, and the 0.33333 times 60 will give me 19.99, which I will happily round to 20 minutes. So it will take 3 hours and 20 minutes to complete, but it's asking me what time it will finish. So if I walked in at 0800 and it's going to take 3 hours and 20 minutes, that means I better be back in there at 11:20 with a brand new bag to hang for my patient. So the answer is I will walk in with a brand new bag at 11:20 because that's when it's gonna finish. Woo! That was a marathon, but thank you for hanging out with me. There is so much more, but this is a challenge. And like I said already, I love that you're going for it. So I've reviewed pretty much everything that's pertinent to taking your exam at this point. You went through 1 factor, 2 factor, 3 factors. You've done IV fluids. You've done feeding, dilutions, and insulins. So you've learned dimensional analysis. You guys seem to really, truly understand your conversions. Please use the resource that's on the YouTube site, not to be famous. It's just the only place I can house that large volume of video. As soon as Zoom gives me this recording, I will post it on that YouTube site. But please just utilize those practice sheets. And if you're concerned about timing, I always recommend timing yourself when you're doing the practice sheets so you can see how long it takes. But as you know, the more you do it, the quicker and more efficient you will become. Also, when you're using your calculators, please make sure you get in the habit of clearing them to zero, because a couple of people said, oh gosh, I got it wrong because my calculator. It's very true. Make sure you're clearing it when you're going in between your questions. And if you finish early, I know most of us want to get the heck out of there, but if you finish early enough, just start rechecking your answers over and again, do the problems again, because every point matters when it comes to these high stake exams. When you do go for your exam, don't forget your ID, your student ID. If you don't have one because the college couldn't give you one, you could bring your driver's license, but the rule is you must go with your student ID. But if for whatever reason you haven't been able to get one through public safety, maybe go there that day to public safety to get it, because the rules are they're pretty strict in.
They don't, they only, public safety only issues the IDs once a week on Tuesdays, and the exam is Monday, so if we don't have it now, then we probably won't.
Is that the only time they're doing it now?
Yeah, only once a week on Tuesdays.
Well, that's
Yeah,
really
work on
They're
Tuesday.
having issues with the machine, so they only do it once a week and during like, I think it's like 8 to 1 and then, I believe like 3 to 5.
But also, if you go
Yeah.
and don't know that and you are just really extra sweet and you smile and you say you drove a long way, they might help you like they did me.
I would maybe try it. I don't know if you happen to be there. I would totally stroll on over and be
Worked
like,
for me.
hey, it's worth a shot. But all right. So if you don't have any other questions, does anybody have any questions? Hold on a second.
Yeah, Professor, so you were saying that you are going to post the video.
Mhm.
So is there any link to go there, or we just need to go to YouTube and check?
Yeah, I have to post it on YouTube because it's too large to post in an email. It would never send it an email. So
No,
this
I know,
this is
like
actually the
the
QR
link.
code if you want to scan that real quick. And I'll post it to the YouTube site.
But
Oh,
can you send us a link to it in our email? I
okay.
think
Yeah,
is
that's what I was asking
yeah.
before.
Well, right here, I can if you scan this, it should take you right there now.
Oh,
Yeah. Like open the camera. Let me just make sure it's working. Hold on.
I think the channel is linked in one of
Yeah,
the
it's in
other.
the actual paperwork as well. Um, hold on, I don't know why the school is okay. Yes, so the link this is also available on the original paperwork, but I'll send it out via email. I'm just afraid I might miss somebody in the email list. So if you can't find it, just email me separately, but I'll try to send, because unfortunately not everybody registered on the same day. So some people registered in December, like December 15th. So all the emails are scattered all over the place. But I certainly will try to send the link again, but it is in the original papers. It's with the resources. It says, literally, it says it has the resources like the Jeopardy Lab, and then it says the YouTube channel. But yes, I will do that. And if you don't get it, just send me an email so I know to send it to you. Any other questions?
Thank you. Thank you.
Thank you, Professor.
You're very welcome. So good
Thank you.
luck. I look forward to grading these exams, and feel free to email me on the weekends. I check very sporadically, but certainly email me and I'll do my best to respond very quickly. All right. But I look forward to meeting all of you in the spring. I'm one of the 118 instructors, so we'll definitely see each other. All right. So thank you very much and have a great weekend. And
Bye.
rest up because spring is coming.
Yay.
All right. Talk to you
All
later.
right. Bye. Thank
Bye.
you.
Oh, look at the
Bye.
doggy. So
Thank you.
beautiful.
Bye.
Bye.
Professor, I do have one
Wanna say
question.
goodbye to
Sure.
everyone?
Since you are the professor for the 118, is there any textbooks that we need to get? Because I don't see that any have been put up.
For 118, the class is just the Davis Drug Guide. The other books, everything is digital.
And will we be given that like on the first day, like with the syllabus?
Yeah, actually, it'll be posted in D2L. We don't even have the shells yet to load anything, but when I load all the information in D2L, the learning management system, in the I think it's under the course information section, it'll tell you how to register for it's called ATI. And you register for ATI, and then they give you then you get the access to the reading.
Should we get used to checking like the D2L, like you said? Is that where everything will be posted?
Yes, everything will be posted in D2L.
I went to the
Everything.
bookstore a few weeks ago and they were like, no, there's no books for nursing.
Yeah,
one
no, the Davis Drug Guide is just the clinical component. So for
Oh.
clinical, you'll need the Davis Drug Guide. And a lot of people, if in 118, you do have drugs to review. So even if you want to get a later, like a digital version that's cheaper online, that's fine too, because we only do like 40 something drugs. But when you move through the program, you will need it because in Good Sam and Nyack, you'll be passing the meds. In 118, you're just going through and learning about the meds. So we don't really get a lot of opportunity to administer medications in our 118 fundamentals. But certainly if there's an opportunity, we're going to take it, but it has to be the perfect storm. So yeah, so for 118, it's all online.
Okay.
Yeah. Cool. All
All right.
right.
Thank you so much.
Rest up. All right. Thank you guys.
Thank you so much.
Bye-bye.
Thank you.